Yes, this is basic geometry. Your flat Earth geometry. Flat Earth geometry. This is basic geometry.
It is.
I called you a flat earther.
My name's Ramsey.
Insisting that your flat Earth geometry will work.
I'm familiar with the bubble, Morty. I also dabble in precision, and if you think you can even approach it with your sad, naked caveman eyeball in a bubble of air, you're the reason this species is a failure, and it makes me angry.
Did he say a five-sided square, question mark?
You're a universal horizontal waterer.
You're drunk.
I called you a flat earther.
You want to experience true level? Do you? Yes. You want to experience true level?
That auto level is establishing a horizontal. That's just the way it is.
Because I've done the test with an auto level, which gives you a horizontal.
Yeah, it's gonna look super flat.
All right, come on. Wow, it's so.
Three coplanar points.
Oh Christ! Yeah, true level, bitch.
I called you a flat earther.
If you're into math, there's a certain shape where you could make a five-sided square.
Are you suggesting that horizontal can't curve?
Oh, everything's crooked. Reality is poison. I want to go back. I hate this.
What's his deal?
Shush. Morty. Go to school, Summer. I'll go on Morty's memory and do a little.
Randy, come on, that's a globe. And he eventually just gave up and said, yeah, I agree, it's a globe.
Geodesic is a continuous string of infinitely small, straight lines.
Yeah, true level, bitch.
It's really flat and level now.
Randy, come on, that's a globe.
Yeah, true level, bitch.
Randy, come on, that's a globe.
Lance to the cosmic slaughter! Well? You seem to be in charge of what I get to remember. Why? Good question.
Randy, come on, that's a globe.
I'll go on Morty's memory and do a little.
Burn right to the ground in pieces. But from the ashes come.
Wow, it's so. Oh my God! Oh Christ! Yeah, true level, bitch.
If you're into math, there's a certain shape where you could make a five-sided square.
Randy, come on, that's a globe.
Yeah, true level, bitch. Wow, it's so. Oh my God! Oh Christ! Yeah, true level, bitch.
I called you a flat earther.
True level, bitch.
I called you a flat earther.
True level, bitch.
I called you a flat earther.
Yeah, true level, bitch.
When you get to the end of this test and you have a result and you say level is horizontal and everyone says big whoop, that doesn't prove anything about the shape of the earth, will you then say yes it does?
No.
No, okay, I'm going to bed. Right.
Okay, so
I'm going to bed.
That level is horizontal is good for you then, right?
I agree. I agree level's horizontal.
Sweet.
Right,
true level, bitch.
Perfect.
Wow.
Nice, mate. I came
Nice.
in just for that. You flipped it, man.
Yeah, true level, bitch.
And we are live. Welcome everyone. That was Buster and True Level Bitch. Or the True Level Bitch mix. Welcome. It is Euclid Day. But I mean, I guess we're finishing off all of this sort of stuff. I've got a few little bits I want to go over. I haven't really prepared anything. Life at the minute is absolutely fucking hectic. So, I don't know what we've got to go over. I think we've only got a couple of things. I've left these guys away from Twitter, right? We went over KC. I think we said we might go over a few more of KC's videos, but I don't know whether that's geometry or model afflicted. I'm guessing it might be better off saving them for Monday. Casey. Then this, I had this. This is on YouTube with Kenny and Darren. For anybody who doesn't know, that we went over the philosophy course last night, and we had a guest appearance by Darren, who I don't know whether we should go over that today. It depends what everybody else wants to think about it. Whether it's worth going over the straight line identity problem that some people seem to have. It's quite a common thing nowadays, but it's blue marble model induced problems. And that seems to be the hot topic at the minute. People can't come to terms with the consequences of acquiring an other geometry. It's a very strange idea. I think it really comes from you not really understanding the first principles of geometry to start off with. So this is Kenny. Kenny says, you act like spherical geometry is only used to describe Earth. Denying an extra branch of mathematics to support your delusion is pretty desperate, Bev. Not a good look. To which I reply, spherical geometry is only talked about by people ignorant of it when regarding the Earth. Reality does not need or require spherical geometry in any way, shape, or form. And Kenny, hopefully, he's one of the blue marble scientists. Hopefully, he can come out and be brave enough like Darren was. He says, reality dictates otherwise, Bev. Stop lying to yourself. It's a bad look. So this is one of those things that I think, I don't know, is it a narcissist trait? Oh, just a minute, I've got a phone call. Somebody else take over for us, please.
Please bear with us during this interruption. I hope you don't mind the dust. We are under construction. Bev has been called away by an interrupting cow. Oh well. Have fun. If I talk too much, I'll start coughing, so I will go back to my little corner. Please bear with us during this interruption.
No problem.
Paper, how are you today?
Like yesterday, and like day of before yesterday.
You made it. You're here. Did you have to get up early today, or was it just a normal day today?
Today is my Sunday.
Oh, okay. I mean, this is an opportunity for everybody to take over, try thinking. Nobody's doing it. It's a golden opportunity.
Are we not live?
We are.
Why is it so quiet?
Beth has a phone call.
Oh, how long's it been quiet for?
Like 3 minutes or so.
Oh, sorry, YouTube.
YouTube has to wait.
Yeah. Unfortunately,
Not about YouTube. It's not about you, Tube. Womp womp.
guys in the chat, you'll have to help out here. And you guys will have to help out. I didn't even hear what Bev started with, unfortunately.
Who's starting to go over Darren coming in last night?
Oh, yeah.
I wasn't here, so I don't know what happened.
Yeah, so we were in the middle of going through the course, and Darren comes in and takes us all off on a tangent somewhere.
Nice.
And it lasted, well, yeah, it went on for ages. I mean, Bev will explain it better.
Yeah.
No, Bev did not say that, Mike. I know that for a fact. If Buster was here, he would sing. But you're not going to get me singing. Sorry.
Nor I.
There we go. See, no singing, unfortunately, guys.
That's right. Me and Emma are objecting.
Yes.
Okay,
Anyone who
I'm
should
back.
be.
Sorry about that.
Yay.
Yay, Bev.
Yeah, it's okay. It's all right. Don't worry about
They
it.
were trying to get me to sing.
It's too
out
late,
there.
Bev. Emma and Constance are going to sing for us.
No.
So stand by.
Yeah, sorry about that. Family matters. I had to take that phone call. Okay, so where are we? Where were we at?
At the Darren.
Yeah.
To be brave.
Yeah, he said reality dictates otherwise, Bev. Stop lying to yourself. That was it. It's a bad look. How can you lie to yourself? What's that about, right? When people say these things, I think they tell you more about themselves than they do about you. How is it possible that somebody could imagine that you could lie to yourself? I don't know how that would be possible. Can't even imagine it. But they obviously must imagine it of other people. So I guess along the theme of the way these things go and what we've been talking about, they can say you're lying to yourself, and therefore they can call you a liar. To everybody. Once they've imagined that you're lying to yourself. That's Kenny. Blue Marble Scientist. I didn't really do many. Do you like that one? So good. Right. Sorry about that. Yeah, like I say, I'm all over the place this week. Where are we? What are we doing? Oh, I wanted to go over this video. I've had it saved for quite a bit. Let me find this. It's a 14-minute video. And I know I keep saying this. I don't think a lot of people have ever seen this. You know, I keep saying about Larry Scott and him telling my son. So I have to set this one up again. We were talking to a guy called Larry Scott, who's one of the guys within this arena that likes to, I don't know, he's the authority at the minute, supposedly. And we were talking about surveying and surveying procedures. And one of the long-standing things has been to do with triangles measured from the top of mountaintop to mountaintop. 3 points making what you would call a triangle. So I've been talking to them, and I had to go and have my tea, so I went with the family to have the tea, and I was telling my son about this, and my son, after we'd finished our tea, he came in because he was that curious. He wanted to find out for himself that I was telling the truth. So he came in to talk to Larry Scott. So this is a portion of a much longer chat that we had with the guy called Larry Scott from this arena. Oh, where is it? Come on. Oh, I'm on the wrong one, that's why. Right, here we go. So this is considering it's geometry night, and I didn't know whether to go over the stuff with Darren, but I thought this is something that I've been doing for quite a while. So let's go over this.
The level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared. I'm not kidding.
Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well,
Sound level. Straight lines don't bend when they get a certain distance.
Okay.
Triangles don't gain extra angles for getting bigger. It's ridiculous, Larry.
Well,
I'm really considering questioning whether you are actually a surveyor.
Okay. Good.
My lad wants to ask you a question, Larry.
Yeah.
See if you can do your best to help
Muted
him
right
out.
now.
Well, it's all right. He's listening.
Yeah, Larry. I want to know a bit more about this. How these triangle angle expansion or something works, because I've heard it from my dad and it sounds a bit ridiculous, but I want to hear it from you. So if I can understand it a bit more, you know.
Your volume's so low I can't hear you.
Sorry, yeah. Can I hear a bit more about this, like, triangle angle expansion or something you were talking about? Possibly.
Sorry, do you mean triangles having more than 180 degrees?
Yeah, that.
Sum?
Yeah, how it,
Okay.
like, when it's small, yeah, it has 180 degrees, but when it goes to a larger scale, it somehow gets more. I want to know a bit more about that, see if I can understand it.
I just posted what the math is involved when dealing with planetary, county-wide, statewide, large area. That's the maths you go through to deal with the triangles, because the instruments are oriented to vertical at each vertices, and plumb lines are not parallel, as we know.
Well, I'm not going with what you've given them. I'm trying to just understand the whole concept, because I'm, like, as you said, I'm a bit young. Just want to know how it works, because from school I've heard triangles only have 180 degrees and all this stuff, so I just want to know how it can have more than that. Like, how? Not just the math involved, but an explanation.
Well, I just put the math up there, and when you get out in very large distances, it matters. When you're measuring over very small areas, it's hard. The difference is very, very small. So, yeah.
Yeah,
Given
but
the shape,
how
given the
does
size,
it have more than 180 degrees?
I put the math on there because
It's not just... I'm not talking about math. I'm trying to get an explanation from you, not just some paper.
Because in a large area with many tens of miles per side and hundreds of square miles encompassed by that triangle, each instrument is oriented to the vertical. And the vertical is not parallel at two points separated by any real distance.
Is he still going fucking on?
My lad's trying to work out.
Yeah, I'm hearing him talking about this, but he's talking about, like, real life, but, like, triangles shouldn't be... It should be impossible for a triangle to gain more than 180 degrees, because it is a triangle, it has three angles. When they're lined up together, the mathematics involved can only have 180 degrees. It cannot go more nor less, how big or how small it is. And that's what I understand, and I've given it as fact, and I'm still thinking about it, and it still seems true. I don't know how in real life it's wrong.
Yeah, it doesn't really need any more consideration, really, does it, Larry? Because he's struggling now. Can you hear him? He's like wondering on the concept of a triangle having more than 180 degrees. I mean, it does sound fantastic. Can you give him some help, Larry, please? Did you hear the big sigh? The big, deep breath
There is no way to explain that.
There's no way. What's he talking about? He doesn't feel comfortable talking to a young person, but he's fine gaslighting adults that he considers, he's labelled them flat earthers. But it's a little bit different, isn't it, when somebody's asking you a genuine question, which is all we've ever been doing here. How ridiculous is it? Let's see how well Larry does after his big, deep breath. Let's see. We go. Listen to that breath again. Some help, Larry, please.
Because the spherical excess increases at about 1 arcsecond per 75 square miles. So if you're measuring a triangle that has 250 square miles, you only have a couple of arcseconds total accumulation, and that is distributed across all 3 vertices. And yeah, that's only like not even an arcsecond per angle, and that is small, and that is a singular arcsecond to high reliability is a serious measurement undertaking.
So, at what point, Larry, does a triangle, when you start with a normal triangle table, how much do you have to increase that for it to start gaining, like, the size and the angle start gaining? How big does it get until that point where it starts gaining on its angle?
Well, at 75 square miles, you have 1/3 of an arcsecond per angle. So if your triangle is only many hundred acres, yeah, the spherical excess is minuscule. But when you get into measuring a triangle that has 800 or 900 square miles, you have a few arcseconds.
So what you're saying is, if you were to have a normal triangle on a table and then just a tiny bit bigger than that, it's always gaining in angles. It's just until that point you're able to see it then and only then, because it's so small of a difference. Is that what you're saying? Trying to understand a part of what you've been saying with this whole conversation, not just the whole, because the whole doesn't make absolutely any sense.
You can't measure a triangle on your table that incorporates hundreds of square miles.
Well, does it, like, if you had, like, let's say, some brilliant tool that you would be able to measure some, like, the extremest of smallest of differences, would a small triangle on your table compared to a triangle just a tiny bit bigger than that, would you see a difference in them too?
No, because you'll be measuring the triangles on your table with a protractor at each vertices. That's all in the plane of the table. But when you get out in the real world, when you level up your instrument to the local vertical and you go 20 miles away or 50 miles away and level up your instrument to the local vertical lines are radial to the center of the Earth.
So even if you had the best instrument that you'd be able to calculate like any distance between the smallest of points, you wouldn't measure. If you were to have that instrument, not just a normal protractor and all of that, would you be able to see a difference? Yes or no? That is the question.
In theory, yes.
Okay.
In practice, no.
Okay then.
Because each of the instrument at each vertex, if it were oriented to vertical lines are not parallel. But if you're only dealing with something the size of the interior of a room, those numbers are too small to even contemplate. That's why it only shows up when dealing with triangles incorporating hundreds of square miles, and the instruments are oriented to the local vertical at each vertex.
Okay,
And
so
radial, vertical lines are radial to the surface of the Earth.
you're talking about a 2D triangle, correct? Two-dimensional.
Triangle. I'm talking about a triangle measured across our Earth, which is a planet. Yeah.
So two-dimensional. So where does vertical come in?
Because that's how your instrument is oriented.
Thought it was two-dimensional though. How can an instrument be oriented in any other way if it is not? If it is two-dimensional?
You know, it's a complicated subject. I gave it my shot. Take the deep dive, the Ordnance Survey, or any other large geodetic textbook will explain it to you.
All right then. Thanks, Larry. I'll try and keep looking into it.
Given the existence of the South Pole, sunrise, sunset, orbiting satellites, eclipses, and tides, yeah, flat is not an option.
For a triangle. What's he talking about?
He was talking about vertical triangles with curved surface.
Yeah.
With curved side, let's say. So, strange thing.
3 minutes left of this. Thanks for that, Larry. How do you think my lad did? I think he did very well. I don't think he got anything
Me
sorted.
too, by the way. Me too, by the way.
He will be looking into it. It's like when people hear these really strange things that they've never heard before, Larry, they get inquisitive. And they want to come and ask the people that say these things how they know that and why they say such things. I'm still of the opinion that triangles only have 180 degrees. I mean, I think you're mad. I think you're claiming that you can do impossible things.
Well, so does the Ordnance Survey. So I could agree with them or I could agree with you.
Well, the Ordnance Survey think you're mad as well. Is that what you said?
The Ordnance Survey has vast wealth of published values on dealing with the large area triangulations. So
it's well known in mathematics, though, Larry, that triangles only have 180 degrees.
Yeah, except when dealing with a sphere, like the shape of the Earth.
A sphere is a surface of constant curvature. There is no straight lines on a sphere.
Well, you have the line of... If you
Can I phrase it?
2 points that are in a line of sight, yep, that is a straight line. How that equates to the shape of the Earth, yeah, that is a point of math. And I could agree with you, or I could agree with Ordnance Survey UK. I'm going to go with Ordnance Survey UK because that matches my experience. What you're saying does not match my experience. I can't go with anything Flat Earth says.
Larry, I'm just saying triangles have 180 degrees. I can't let that go. What's up? Sorry. I'm saying triangles have 180 degrees. That's not flat Earth.
Okay.
It's mathematics.
Take a soccer ball and draw a triangle on it and measure up those angles.
You can't measure an angle to a curve, Larry.
Oh, yeah, there you go. Then we're done. I don't know what else to say. You said you agree with Ordnance Survey UK, and I thought that was common ground. I bring that to the fore, and they're all about the shape of the Earth, that you do not agree with the Ordnance Survey UK, apparently. So I brought that up as common ground.
They don't measure angles to curves, the Ordnance Survey.
Except when they say they do.
Wow. Okay, so there you go. That's Larry Scott. the only one that they have left in this arena that seems to have gone missing also. I don't think he can talk about anything. Larry Scott, ladies and gentlemen. When I talk about Larry Scott telling my son that triangles have more than 180 degrees, you've just heard it for yourself. That's a grown man within this arena telling a young lad that triangles gain angles when they get bigger using line of sight. And the only explanation he gave him was Ordnance Survey do it. Well, the Ordnance Survey don't measure impossible triangles. It's not how it's done. So that's why one of the reasons why I'm not too keen on the claim to be surveyors within this arena. I have a reason to deal with, well, to feel sort of a little bit aggrieved at the lies that people tell other people within this arena. Surveying is entirely geometrical. And I think yesterday we had the philosophy in the Discord, which is so much better. Not have to deal with distractions and stuff. So yeah, it's so much better. But we had Darren come in. Should we go over that? Does anybody want to go over that? Because this is Euclid. And we've just heard from Larry Scott telling a schoolboy. He's not at school now, but when he recorded that, he was at school. He was 15 years old, I think. So why would Larry Scott tell a schoolboy that triangles have more than 180 degrees? Theoretically, he said, theoretically, if you have a tool that can measure it, it would be able to measure the increasing angular size of a triangle.
But wait a second. If he was talking about surveyors who do that, so they don't do that theoretically with theoretical tools.
Yeah, well, my son was talking about a triangle on the table on a piece of paper, you know, just increasing the size of it, making more angles. And Larry was saying, well, there isn't a tool that can measure that.
But still, it is not proven that surveyors have that kind of tools.
He did say over multi-mile square areas, but we had a guy that may or may not live in Maine that we just went over the other week that said he did it over 500 meters. Now that isn't multi-mile thing, is it? Definitely not. So they do have a bit of a conflict between the people that are talking about these things. Now, it's hardly surprising that Jesse Kozlowski did a Jesse Kozlowski, and then also the guy that may or may not be from Maine also did a Jesse Kozlowski. George, God rest his soul, attempted to solve the horizontal paradox 180-degree problem, right? That's the problem with the horizontal paradox, is that a straight line has 180 degrees, but they've got to fit more. Got to fit more than 180 degrees in. That's the blue marble science induced horizontal paradox problem. The judge tried to solve it. I'm going to get round to it. But the problem becomes centered around the straight line. And we had a guy come in yesterday as we were going through logic night. We were going over Aristotle and the basics of logic, going over the organon, and the first principles of logic are based around the, I think you call them the axioms, call them the whatever, but they're laws, the first principles. And the first one is based around the law of identity. That's the very first law. And I call them the law of communication. And obviously, because of that law being violated, that's why it becomes really difficult to be able to communicate with people around these sort of things. So what's everybody thinking? Do you want to go over that bit last night with Darren and the straight line?
Sure.
Yeah, I think. Let me get it. I've got it cut. I'm cutting it. I've done the other the full version of this, but I think this is so poignant at the minute that I'm cutting this particular part out on its own. Don't think anybody on YouTube needs to actually see this screen. So I'll put the live chat. Somebody keep an eye on the live chat or whatever as we're going through this. Right, okie dokie. Here we go. So if anybody wants us to stop, we'll go over it like we did do last night, right? Anybody notices anything pretty specific, right? So remember that we've stopped being live. We've gone into a Discord session and we're going over a university course on an introduction to Western philosophy. And we've just watched the entire lecture. You can you'll be able to see this one tomorrow if you listen to it. So we go over this and then we're talking about there was no further questions or anything, so we started talking about the laws of identity, and I think I just start queuing it up and then Darren comes in. So this is the bit where I've got it started from. It's the bit I'm cutting. First principles of communication, because it's sort of how you can not only understand yourself but have a conversation with somebody about something. If you don't have all of these laws in place, then I don't believe that conversation can occur if you don't agree on these at least basic principles together. And now we have gone over these. Law of identity. He's put law of identity 1. Each thing is the same as itself and different from another. I think that is pretty simple.
Yes, so straight line is not straight line, and not straight line is curved line. Therefore, straight line is not curved line.
Yeah. They cannot be the same thing. identity of the thing, right? I think this is the part that identifies the thing, right? This is where you relate something to reality. You say that thing there is that's the thing we're talking about, the identity. It's not something else, right? It's nothing else is this. It's this thing.
So going back to the straight line
There we
thing,
go.
which is very dear to my heart, as you know, what you're creating an identity where there is none. That the word straight is not the identity there.
Right. So again, I'll have to point out that we're literally just talking about the law of identity, and we're talking about straight having one of those things. It has an identity of straight, and Darren comes in with, I don't know. I'm still struggling to understand what Darren's problem is. See, it seems unexplainable. A bit like Larry trying to explain why a triangle might gain angles as it gets bigger. There's just nothing there. There's no words to describe it. Let's see.
Definition of a straight line is the identity, and the definition of a straight line in those two situations, paper, is not the same. So in Euclidean,
right, so he's basically saying that paper said about a straight line and a not straight line being different, and Darren says that the straight line is different. It's a different definition, which I think is violating the law that Paper's just talked about. Again.
Two situations, paper, is not the same.
It's not
so
the same.
In Euclidean geometry, straight is the shortest distance between 2 points and all points on that line in continuation. But in the spherical case that you mentioned, the straight line, and straight in quotes there, is straight is just a word used to describe that shortest line on the surface of a sphere.
You mean the not that quotes?
Wait, Darren.
Yeah, so he said straight in quotes.
Yes, so this is different straight, not that straight.
And I think he thinks that he can avoid violating the law of identity by putting straight in quotes. Which, I don't know, would be fantastic, really, I think.
Wait
as
a
an
second.
argument.
When I say straight, I am using, of course, Euclidean meaning of straight.
Yes.
And
we said it at the beginning, though. We have already been over this. Straight and one, they're self-evident. Surely that's the straight that everybody's talking about, right?
No, but it's not, right? So they make it very clear in spherical geometry that they're not talking about the same straight.
So, okay, so yes, so you are talking about straight being not straight in the same regard. So you are changing meaning of the word. It means that this previous meaning of the word is just meaningless for you. So, but still,
No, it's more of an analogy than a direct translation. So
it's more of an analogy than a direct translation. Literally said that about this new definition. It's more of an analogy.
Wrong. This is wrong. Analogy has to have something similar or identical. So
he's analogizing a straight line from a straight line.
Just not nonsense.
Yeah.
You are not in geometry and in science. You are not making analogy.
This is sophistry, right? But I think it's freeform. It's like jazz sophistry. He's making it up as he goes along. There's no plan to this. Ignorant of the geometry that he's dealing with, and ignorant of the first principles, and even the correlation between the geometry and the first principles. He's ignorant of the whole thing.
In geometry, we are dealing with strict meanings of the words, not just analogy. So we are not telling tales.
Yeah, this is deductive logic, right? The most perfect deductive logic there is, geometry. Wrote down in a rule book, right, with all of the proofs within it, all there. And he's analogizing it. I think it's fantastic.
We're using the term straight as an analogy to a straight line on a plane. That's the thing. That it's just a word. Its meaning is used for convenience and comfort.
Do you want to hear that again? Because that, like, just those words. I don't think we've ever even heard somebody like Rumpus say this sort of stuff. It's great.
No, but it's not, right? So they make it very clear in spherical geometry that they're not talking about the same straight.
So, okay, so yes, so you are talking about straight being not straight in the same regard. So you are changing meaning of the word. It means that this previous meaning of the word is just meaningless for you. So, but still,
it's more of an analogy than a direct translation. So we're using the term straight as an analogy to a straight line on a plane. That's the thing. That it's just a word. Its meaning is used for convenience and comfort, so that people, as they move from one set of mathematics to another, have some commonality that they can feel comfortable with, and term.
It's used for comfort.
Yes, how to easy deceive people. Yes.
Just so you feel. I mean, we call it straight, and you know, we argue that it is straight, but it isn't really. It's just for comfort use.
Yes, for psychological reasons.
Yeah,
we keep it the same word to not disturb people.
Mentally, obviously, mentally, right? It can at least keep straight as a sort of semi-mental construct. Later on, we'll explain to you that your entire definition of straight has actually been ripped from underneath your feet.
That kind of makes sense to them.
Yes, I would agree with that, but still, you are saying about line on a sphere or line on a plane. But the problem is that line is before any surface. So we are talking about line in space, just in space, not on some surface. We are not talking about surfaces. We are talking about line, distance between 2 points in space. It does not require any surface. So, so this distinction between line on straight line on a plane and straight line on sphere, it doesn't make any sense because line does not require any surface.
I think at that point, right, it is worth noting that it is the straight line that forms the plane. The straight line comes before the plane. This is what I'm saying about Darren. I don't think he sees the first principles are the things that the things are built upon. He thinks you can just sort of play around with this stuff at the beginning. It's very strange. As this develops, it's it becomes pretty clear that whatever's going on here is a psychological problem, and Darren is unaware of the true implications of the geometric reasoning, and he's just purely a sophist, practicing sophist within this. Although Darren, whoever's watching, can imagine that they are far more superior in intellect. Let's see if anybody can come and discuss it, because I think this is a fundamental break that we've made. People have been going for years not mentioning this. This is an inconvenient truth that shouldn't really be spoke of, and Darren's decided to join us doing this. Thank you, Darren.
I guess the line on a sphere doesn't require a surface either. It's just the surface is a convenient reference point, like the plane is a convenient reference point or reference concept. In the case of the sphere, we can just consider it as an arc in space if we wanted to. Which is where spherical geometry realigns itself with Euclidean geometry, right? They're just arcs in space.
Darren,
and we.
Yeah. Can I ask you, have you ever heard of a stolen concept fallacy? Since we're talking
but
about
I'm
logic.
not an expert in it, Bev. So yeah, I can't.
Well, it seems to me what you're talking about is you're using a sphere, which is like quite a few steps along the geometric train of thought. Book 11. I think this discussion is going to be an excellent learning and teaching tool, because there aren't going to be many Darrens that can come out and voice this stuff. So you would never usually, I mean, we've known about this as a consequence of a model that's been brought forward, but I don't think anybody has ever let let's say the cat out of the bag in saying what Darren's saying now. It sounds far too fantastic for you to even believe people get led into this, but this is how simple an argument can be whenever you sort of delve into first principles. And arcs in space would require another point. Obviously, you require a center point to form an arc. He doesn't seem to see that. Arc is made by a straight line. So there's so many different ways to see this, but mainly what you've got to try and do is, and don't Penrose yourself while you're doing it, or even nutsack yourself. God rest his soul. Try and imagine, but not too much, the ridiculous concepts that you're having to go through here to imagine that straight is somehow different than straight, because that's what they have to do here. They may say something different, but the end goal of this geometry is to make you realize that there is no straight. It's like a Matrix thing. The spoon, there is no spoon. Well, this trick is there is no straight, whilst calling something straight, to ease you into a comfortable grip of geometry that isn't there. They're going to just evaporate all of your geometric concepts once you're led into this. Darren's trying it with sophistry. Larry was trying it with triangles. people who are inquisitive. There's many different ways these sort of things happen. And then you're taking that sphere and bringing it right back to the initial first principles, the beginnings, and you're realigning straight from those first principles, the ones that you used in order to make the sphere, to turn that straight into something that it isn't. Which I would say that's a stolen concept, because you're taking something that needed the straight line to be formed, to bring it back, to turn that initial straight line that helped make the sphere.
That's what I was going to say. Is how did you get the sphere in the first place?
Yes, you need straight line to produce circle. You need straight line.
So we all acknowledge
And-
spheres are a thing, right? Spheres exist, arcs exist, and they are described in Euclidean geometry.
See, this is where it blatantly shows that he's either ignorant of the fact that a straight line is needed to form these things, or he's purposely being deceitful because he knows that the end goal of the trick he's playing is there is no straight. One or the other. It depends. I don't know who leads it, and there may be different ulterior motives from anybody that's dealing with this sort of stuff. And I'll have a conversation with anybody about it. It would be really good if we can have a conversation about this sort of thing.
And a lot of the properties of spheres and arcs and their intersects and surfaces and things are all talked about in Euclidean geometry. It's just that when they developed spherical geometry, they stole the term, but the meaning is not the same.
They stole the term. That term is straight. Now, I don't know whether he's got that because I call it a stolen concept. Not too sure. It's not because they steal straight. It's more commonly known as a self-refuting claim. And that is made easier to see that the straight line is the term that you're dealing with, and it's self-refuting. It refutes itself. The straightness is self-refuting. It's a ridiculous thing. I'm pretty sure it's not even in the organon, because it's that ridiculous.
Yes, it is definitely too stupid.
He wouldn't have
to
even.
put that
That's like not
in
even.
organon.
We don't. I mean, Euclid even said, he put in as one of the axioms that two straight lines cannot enclose a space. So that's how detailed they were whenever they went into things. And Aristotle couldn't even be bothered putting in this one because it's so far removed from any sort of viable argument. I don't know. It's like you're assuming your opponent is stupid. This one, it's like a magic trick, but it's not even a magic trick. They just say, "Da-da!" Like drink a glass of water and go, "Ha ha ha! It's gone." That's how bad this magic trick is. Once you realise it,
And they also, with conversation with your son, Larry Scott is stealing triangle. So here Darren is stealing straight line, and he admits that. And Larry Scott and others are stealing triangle and squares and every
it's the straight line
Euclidean
again, isn't
figure.
it? Yeah, they're stealing this first principle idea of geometry that governs reality, right? It's not just somebody wrote it down and we can just define straight differently within a geometric concept, but no definitions or anything mentally, I think.
We cannot do that because if we say straight, it means that we have connection to reality. We can compare this word straight to reality. We know what it implies in reality. But if Darren is saying that he just changes meaning of the word, he did say that exactly. So what is the link to reality then? There is none. So this is just unreal. Just unreal.
Darren says, unfortunately, I can't dial in today, Bev. It's a shame I can't defend myself against your inability to accept that we can change the usage of a word with the context it is used in. Straight is what we're dealing with. The very first... Well, it is the first principle of the first law within the law of communication or logic, really.
But still, Darren is not justified because his meaning of straight is already occupied by other thing. And he said that in discussion also. This is arc. So this is not just new reality, unknown reality. No, this is just replacing straight with new, not new meaning. He's just replacing straight with a curve. And a curve already is in geometry. So by changing this straight, name straight, he is getting rid of curve in language, let's say, because this meaning is already occupied by word arc or curve. So this is just not justified. You cannot just do that because you like. It's just nonsense for me.
He's tied up. He can't come in and defend himself. So we'll make sure if there's anybody that thinks that, that we're unjustly saying something about Darren's words that, we can go over. If anybody thinks that something could have been misinterpreted, let's go back over it, go over this, because this is the first principles of all sorts of things, really. First principles of, like the first principles logic, and logic goes through everything. It's thought. So that's what we're dealing with here now. So if anybody's got any sort of opinions on straight that we're not aware of, because, it is straight. These could be new blue marble science methods of understanding of straight. New mathematics. I'm over 50. I might not be up to date with this new modern day mathematics and the understandings of straight. Well, let's go.
As in one-to-one, they haven't... I guess they've taken it as a term of convenience, that the geometry is not in conflict with Euclidean geometry. It's only that the mathematical constructs that they've developed around spherical geometry as a convenience to working on with things that are inherently happening on the surface of the sphere or in a spherical space. They've just used similar terms. They're not trying to say they are the same thing. They're just trying to say it is like this. It has.
So what is straight then?
In the same way.
What is, if you turn straight into a different straight, what is the first straight? What happens to that?
Yeah. So the first straight is a Euclidean straight line, right?
Yeah.
The
Just a straight line, right?
The second one is formally a great circle, right? An arc, and an arc through a center of a sphere. And we just the word straight is just used as a convenience word. It's not redefining the Euclidean or conflicting with the Euclidean straight line.
It actually is, because your pi is not the same.
Yeah, the whole pi thing, right? Which if you consider
Spherical pi,
just
blue marble science.
Yeah, it's We don't need to distract ourselves with pi, because that's just a...
Yeah, you do, because you've just changed what the meaning of straight is into a curve. Pi is directly related to the diameter of a circle, which is straight, like your initial starting straight,
so
not your new straight.
Yeah, if you've got a classic circle,
a classic circle.
Yeah.
There you go. So it is apparently, this is a new mathematics, because the circle is now a classic circle. There's a new modern day,
opposed to new modern circle.
Yes,
so
modern day circle.
Yes.
Good afternoon. I just started
Rob.
in on the craziness. All I heard was crazy.
Yeah, well, this is going over the law of identity, really, from a logic university course, going over the first principles of logic.
That was talking?
That's Darren.
Darren, right. He was here the other day.
Yeah, this is Darren from yesterday.
Yeah, he doesn't know that spherical geometry is just two-dimensional representation on a three-dimensional sphere.
I think
I don't think he got that part.
Yeah, you come in again in a bit. We can talk about that when we get there. We should be coming pretty soon, I think.
I'll go back on mute.
Yeah.
Yeah,
come on. You've got. This is starting to sound a little bit ridiculous, right? Because we are talking about logic, the first principles, and the law of identity. Now, you've started with straight, and I'd say the absurdity of that is pointing out that you can't form a circle without a straight being straight.
No, I didn't say that. So in Euclidean geometry, and when we talk about a circle with a radius and a
There's
diameter,
no need to say in Euclidean geometry. We're talking about straight here.
No, that's the point, right? So you're trying to use the word straight to corrupt the meaning.
Did you hear that? Do you want to hear it again? Because I think this is pure sophistry.
Yeah, because isn't that what they're doing with the word straight?
Hey, yeah.
Yeah, that's exactly what he's doing with the word straight.
Yeah.
Okay, I'm back on mute. I'm sorry.
Imagine these words coming out of somebody's mouth though when you're talking to them.
No, that's the point, right? So you're trying to use the word straight to corrupt the meaning.
No, you're trying to use the word straight to corrupt the meaning of what? Straight? There's nothing more fundamental that anyone can ever think of. Nothing. Yet this guy is trying to gaslight. Oh, sorry.
Not straight curve.
Yeah. He's got it in his head. And that straight is curved. He's gone through the mental process of this. indoctrination into the dogmatic globe model. And it's took him that far that he's not sacked himself. He's lost the meaning of straight. And if you mention to him the old traditional meaning of straight, not this new modern one that he's got, he'll say that you're corrupting straight. There's dangerous sort of territory when you get to this. People say that I'm obsessed, but we were going over a logic at Hillsdale College. We was a study group, and this is one of the consequences of us actually talking about the first principles of logic. This is what happens to misologists, I think. This guy's got a model to defend. Sort of what I've been doing, I think. There's definitely piecing pieces of this stuff together to show how the mind can be corrupted by, I don't know whether it's just the model or whether it's influences of other people, and how you can be influenced by different tactics. Sophistry, I think. Influenced by sophists and deceiving magic tricks of words. Just everybody knows it's self-evident what straight is, the same as one. It doesn't, it's your starting block, first principle.
Wait a second, but if we have a radius, straight line, Euclidean straight, or not really not Euclidean, because before Euclid, Plato also.
I'm happy to use the word straight line, and
but wait a second, I am going somewhere. We have radius, straight line, and with that straight line, we are producing, in your spherical geometry, we are producing straight line, this great circle. So it is contradiction, because it is obvious that we are producing a circumference, and circumference is not straight line. But you insist that this is, in spherical geometry, it is straight line. It means that great circle and radius of this sphere are the same, which is absurd.
No. So, but we're also, we need to remember that anytime we talk about the line on the surface of the sphere and we say it's straight, we mean great circle, right? So but when we talk about a radius from the center of a sphere, we know it's a Euclidean, a straight line as Euclid describes, right? So the term straight is confusing, but it is, and it's being used.
It's not. Do you hear that? The term straight is confusing. Darren.
So the term straight is confusing. Describes, right? So the term straight is confusing.
Who's it confusing to? Is anybody here? I don't want to misrepresent Darren, but I'm not confused about the term straight. I'm absolutely certain that I understand it. Anyone else confused?
Yeah. Only if I had this model that I lived on a spherical object would I have this complication in my mind. Thank you.
Well, we were going over this, and these basic laws are what was the last one again? I keep forgetting that. Sufficient cause.
Sufficient cause, yeah.
Yeah.
But still, I noticed just now that he is making special pleading fallacy, because he said that this radius is outside of the surface of the sphere, which is true, but it means that space inside the ball has different properties than surface of this ball. So, and we know that this is not true, because space is just space. It doesn't behave, this space, differently because it is occupied by some spherical surface. It's still the same space, but he is implying that inside of the ball or sphere or whatever, the straight line is normal straight line, but on the surface in the same space is different. So that would be, for me, a special pleading fallacy. He's creating special space, fragment of space, being surface of the sphere, and only there are different laws of geometry. But outside of that, we have still normal Euclidean geometry. This is just, yes, special pleading fallacy.
Yeah, he wants that and not that, right?
Yes, outside of this surface of the sphere, okay, we can have normal straight line, but on the surface of the sphere, no. This is special place where these laws are not binding, let's say.
It does end up with extra problems, though, right? Because you can't combine that and not that in any sort of coherent way at all. Ends up with internal tangent chord planes, all sorts of weird thought processes.
It produces many absurds, yes.
Yeah, and those absurds can be shown. Like, that was something else we got from, I got from it anyway. The ability to be able to show these things that are supposed to be self-evident, actually unprovable. Unprovable in the positive, but can be proved true through showing a reductio ad absurdum, right? Absurdity. By showing the absurdity of it not being true. So yes, there are proofs of these things that are self-evident. Maybe offensive to some people, but to find that out.
So the term straight is confusing, but it is, and it's being used.
It's not confusing, though, is it? There's only you that's making it confusing. This is what the law of identity. And we're talking about the first principles of, well, geometry, right? Thought, what straight is. You can't get that confused.
So you can have a mathematical definition of a straight, right? There are mathematical definitions of what straight is.
Yeah, thought. See, here, this is why it's so great going over this. This is a mathematical definition of straight, which he thinks is some sort of equation. He doesn't place it within the mind, within the philosophy, within the map of reality. He doesn't place it on the divided line and say these mathematical objects are above vision. This guy places mathematical objects within a formula. It's got a different understanding of mathematics. To me, anyway. But again, I haven't been to university to do any of this sort of stuff. Logical, meaning...
No. There's mathematical definitions of what straight is as well. So Euclid didn't have a lot of the tools that mathematicians have these days. He didn't have the mathematical... what's the term I'm looking for? Mathematical
Mind.
vocabulary.
Didn't have a mind.
Yeah. So to have a what? But yeah, so he didn't understand about the tools we have now, like
He didn't understand. Euclid didn't understand about the tools we had nowadays to redefine straight. Obviously. Because Darren doesn't have a similar idea about straight and mathematical thought and what Euclid did than I do, apparently. Didn't understand. Did you just...
Come on,
he
Bev,
didn't
you know that
understand
Euclid
about
was born
Euclid.
1,000 years before calculus was invented?
Invented?
Yep, invented. That's what mathematicians do. They invent things, they discover things. Euclid was a pioneer. He was a genius, no doubt, and a pioneer. But
Do you
he didn't
think
have the tools that people developed in the 2 millennia since then.
Do you think he invented straight, Darren?
No, he didn't invent straight, Bev.
Well, where did
But you know
straight
about
come
calculus?
from?
He didn't ever use define lines mathematically. He just says it is what it is, right?
Yes, self-evident, yes.
Mm-hmm. Yeah, obviously everybody knows what straight is.
That's it. And I'm sure that he knew how to use words in different contexts as well.
It's in fact, I'm not too sure whether there's a toss-up, right, between tis globe and the knowing of what straight is, right? The elementary thought process of straight is similar to tis globe, right?
That's what I said yesterday, right?
I mean, you can't get mistaken about tis globe, but
in a different context is not my problem. You need to be able to switch contexts and think about how the word is applied in a particular context.
But this word, like straight or triangle or point, there are general terms. They are not in context. They are out of context. They mean
Use them in
the
context
same
if you want
everywhere.
context, right? English is a language. You can use it however you like. It's probably one of the most corrupt and imperfect languages in the world, right?
English.
English is a horrible
We're
language.
talking about the
So
mathematical understanding of straight.
Yes.
No, we're talking about the use of the English word straight, right? We're not talking about the mathematical usage of it here. It's about how we interpret the word. There's no doubt about the mathematical interpretations in spherical geometry, right? It's only when we use an English word in multiple contexts that you get upset by it. The mathematics is free.
Nobody's getting upset about straight. At least we're not.
No, you are.
Are you okay?
You are.
I'm not getting upset about straight.
No, you are. You cannot disassociate the use of the word straight in the context of a line on a sphere as a useful term of reference from the definition of straight that Euclid uses, right?
I would say that straight is a general term and it means the same everywhere. There is no different, because
Well, I posted an example the other day of a picture in the chat, right, of a road. It was a straight road. It went along straight. You didn't have to turn. You just drove straight, right?
I didn't get to
in everyday
see that.
use, you would say that is a straight road. But it had curves in it, went up and down. But you would still call it a straight road, right? Same word.
It may be called straight because if you are up or above this road, you would not see, let's say, curvature.
That's an excellent point, Paper. What do you get when you look above a great circle?
But But still,
A
it
straight
involves your
line.
side. It involves
See?
your side
So
because
we've
you
used the
can
same
see.
word in different contexts, right? And it was perfectly
No,
acceptable.
no,
We all
absolutely
understood what
not.
it was about.
Absolutely not. We are saying that it's straight in regard to our vision only, because
Yeah.
from a certain angle it seems to be straight. That's why
Yep.
we can say that.
And that's why they use the word in Euclidean geometry. I mean, in spherical
No.
geometry, that's why they've used straight as a convenience, because if you look at a
It
great
is
circle
not.
arc
It's a convenience.
from within the
Did you just
plane,
say
it's
that?
straight.
But I am sorry, but this contextualize meaning it is not geometry. This is not science. This meaning of this straight, allegedly straight road is not scientific. So you are.
It's
You
the
have to
same.
add,
It's exactly the
no,
same.
no, because
It's
you
okay. In
cannot
that case,
use.
then we can simply abandon the use of the word straight in spherical geometry because it is not a technical term used in spherical geometry. They use points, antipodal points,
What's
and
your argument
straight
then,
circle
Darren?
arcs.
What's your argument then? Can you restate your
My
argument?
argument is that you're making a straw man out of the word straight as an argument against the existence, and I say that literally, Bev, the existence of spherical geometry.
No, dude. We
You
were
deny
talking
that it
about the
existed.
law of identity pertaining to straight. You're trying to change it into well, that means that I can't have spherical geometry, and you're telling me I can't have well, no, we're just saying
No, you
that
said that.
straight.
That's how this conversation started yesterday.
The idea
Paper
was
said
that
spherical
straight.
geometry doesn't exist because of the contradiction in that term. He used it as an example as a violation of that law, right?
Well,
And
is it?
and
Is
I'm
that what you're
and
saying
that's
then?
how I started the conversation. That I said, no, is that actually true?
Well,
Wait,
there's
wait,
many
Darren.
violations,
And that's how we
Darren.
went off, right?
Not just that one.
Darren, but still, this straight line in spherical geometry is already occupied by arc. So, and I ask you that question: why you don't use a word which already exists and could exist in spherical geometry, like arc? Why you don't
They do.
just
When
say
you
that
do it
great circle?
formally, you use the word arc or great circle, or and the word straight is not part of the formal language of spherical geometry.
Oh,
okay. We're talking about an informal use here. Hang on a second. I've got to go on mute.
So this is straight is not part of spherical geometry.
Okay, well let me just get this thing again. I'll get a tweet that I got sent the other day. This is from a Canadian school teacher that says great circles are straight. Come on, Bev, learn something. So is Darren saying that we should learn that or we shouldn't learn that? What's he saying? I don't know, they're awfully contradictory. Have to be.
I have a question. Could two arcs be perpendicular?
Well, we do get to that within the conversations.
Oh, okay. I'll wait then. I'm back on mute.
Did Darren say yes then?
Yeah. The lines of two arcs can be perpendicular when they cross. Yep.
Okay. Are the like longitude and latitude, are they perpendicular?
Yes.
What about plumb and level? Are they perpendicular?
Yes, plumb and level are perpendicular.
What about vertical and horizontal?
That's the definition of level A3 is a line perpendicular to plumb.
Okay, what about vertical and horizontal? Are they perpendicular?
Yeah, right. But this is where we go down the same path every time, right? So vertical and horizontal are perpendicular at a given vertical. So
they are perpendicular then, yeah? The same way as vertical, level and plumb are perpendicular.
No, it's not the same way.
What? It's not the same perpendicular. Is there a different perpendicular?
Absolutely. You've got it. every perpendicular, every vertical. Did you say vertical or perpendicular?
So
I'm walking, I can't.
perpendicular.
No, yeah. So I thought you said vertical.
So we've
every
got the
vertical
same
is unique.
perpendicular, right? There's no different perpendicular.
No. So each plumb has its own level, right? So the perpendicular to each plumb is a level.
Yeah.
And or it would be considered as level, right? So we're also corrupting the language here that level has multiple uses in the English
You're
language.
corrupting the language, did you just say?
Yeah, or corrupt. Yeah, that's the wrong word, but anyway. Yeah, so each.
This is yeah, we do Euclid. Yeah, this is Euclid night, right? Yeah.
Now, the English language is inherently corrupt.
We're talking about the first principles of mathematics.
Yeah, well, that's right. And so, going back to spherical geometry, because the plumb level thing
is that what you're corrupting?
It is. No. Going back to spherical geometry, you using the word straight is not the first principles of spherical geometry, right? The first principles, and I kind of disagree with Casey here in her hardline stand about the word straight, that it's a term. It's not straight in the same sense as a straight line. The lines are straight in one dimension, but they have curve in the other. I think the use of the word is not helping here, particularly given that it's not required.
You just say there that in one dimension. Which dimension is there no curvature in?
The plane of the arc.
The plane, but the plane is two-dimensional, and the arc that you're casting is two-dimensional. Right? It's not just one-dimensional, is it?
A plane in space, right, is kind of a one-dimensional thing in the third dimension. If that makes sense?
No, it's 2D. It's 2D. A plane is 2D.
To draw something on the surface of a plane, it has those two dimensions, so that you can consider that
2D.
third dimension to be flatness, right?
No, you consider the plane to be 2D, and you add to that
what if in
another
reality,
dimension.
Okay, so say I draw a line on a pane of glass, right? The line can have curvature, but if I consider the line as not being a two-dimensional thing, even though it kind of is, that say it has some infinitesimal thickness, it has no curvature in the direction of that thickness, right?
There is
it
no
curves
thickness.
as we draw along the plane of the glass.
That's the dimension
but there's
that's
no
missing.
curvature in the direction of the plane of the glass.
No, there is no dimension there. You're only dealing with two dimensions. And if on that two dimensions,
a physical line drawn on the board has 3 dimensions. It exists.
Okay, so everything in reality has 3D. So that's where we're going to start off with, right? If we're going to deal with reality and not the conceptual mathematical part, if we are literally dealing in reality, then as we know, everything in reality, as you've just expressed there, is 3D. Okay. So we've left all of that conceptual geometry with all of the numbers and primes and all of that sort of stuff, and circles and triangles and squares. Left all of that behind. Now we've entered into book 11, solid geometry, 3D, reality.
It's not just book 11. Solid geometry is described in lots of other books as well. Euclid wasn't the only person to ever describe it. But anyway, go for it.
Okay, well that's where we are. So and well, now you're dealing in reality, so you can forget about 2D. It's a bit of a tricky position for you to start off with, right? Because now you're going to want to revert to a surface, aren't you? And get rid of a dimension again.
If we're dealing with reality...
Are you going to try and get rid of the dimension of straightness?
So you're talking in... You're talking about what specifically here?
3D
trying to do.
reality. That's
Yeah.
we're talking about the real globe, right? Reality, where we all live. Everybody knows this.
Yep.
Okay. Now,
one day you'll actually tell us what you think the real globe is, Bev. You seem reluctant
reality.
to stand by your
Reality.
beliefs, and you're probably incapable of describing.
Are you understand? Can you not understand what reality is?
I understand what reality is, but anyway, sorry. Go on.
Well, that's it. You're dealing with reality now. 3D.
Yep.
Okay.
Yep.
So, what's straight to you then? Within
straight
reality, yeah, on the real globe. In reality, what is straight?
Yeah. Well, my definition of straight in reality probably would align with Euclid's idea of straight, in that it has something with no curvature that doesn't deviate from itself. Itself. I can't think of the word he uses, but self something or other. But yeah, so the line, something that is straight.
It lies evenly between its extreme points.
That's the thing. That's the one. Yeah.
Okay.
So, yeah, and I'd say that would be straight, right? In all dimensions.
Like something like vertical. I'm pretty sure we went over this the other day.
Yeah, a vertical line is straight. Yep. For all practical purposes, yeah.
And so perpendicular to that vertical line, a plumb bob, would be.
Yep.
We've got two things there, haven't we, really? If we call a plumb bob vertical, then we can say perpendicular to the vertical
if I was
is
at the plumb bob,
and perpendicular to the plumb is level.
You would say that, yes. If you're standing at a plumb bob, you would say that perpendicular to it is level.
And horizontal.
Yep, at the plumb bob, you'd say that, yep.
Okay. So perpendicular to a plumb bob is both level and horizontal.
Yep.
Would that mean that they are the same?
Level and horizontal? At the plumb bob, yes.
Okay.
At that specific plumb bob,
now
that level and that horizontal are equivalent.
Okay, so now can I just check with you? Is that flat Earth?
No.
No.
Flat Earth is when you say that all
level and horizontal.
No,
that's when you say level and horizontal are the same.
No.
That's what I've heard.
When you say that level is planar, that is flat Earth.
No, you just say level and horizontal. Level is
so
horizontal.
All of level are part of the same plane. That is flat Earth.
Perpendicular to vertical, you have just said, is level and horizontal.
At the vertical.
But you understand what perpendicular is, right?
Yes.
So if vertical is one of the straight lines, and at some point you have perpendicular to that, right?
Yeah.
And if that perpendicular that is perpendicular to the vertical is both level and horizontal, that means that it is the same thing there. At least at that one point, level and horizontal
at that one point,
are the same.
That's it. Yeah.
Well,
so
that's where flat Earth is. That's where flat Earth
Yeah.
is. That's the place
No.
where flat Earth exists, right? By the rules of if level and horizontal are the same, and if you say level and horizontal are the same, then that's flat Earth. Because Fight the Flat Earth has said that, right? So that you've just admitted that at every point where you have perpendicular to a plumb, that's where flat Earth is.
No.
Does that not make you feel dirty, that?
No, flat Earthers.
Because I wouldn't say that's fucking ridiculous. There's no flat Earth there, right? But that's just what I've heard people have told me.
Flat Earthers believe that all of those planes are parallel. That every instance of a level is parallel to every other instance of a level.
Perpendicular to vertical.
Levels are parallel, right?
Pardon?
Yeah, perpendicular to vertical. So that's what.
So all of the perpendiculars to one vertical, all perpendiculars to a plane, will be parallel, right? So all of the perpendiculars to a vertical will be parallel, right? At least you'll admit to that.
That's right.
Yeah.
Yeah, that's true, right?
It
If you
is,
take
yeah.
one
It's a
vertical
geometric
line,
proof,
you
isn't
can
it?
draw as many perpendiculars as you like, they'll all be parallel, yes.
So all
But
of
what
the
flat
levels
earthers-
that are perpendicular to that vertical would be parallel, right? You could be classed as being parallel. Geometrically.
No, there's only one.
What do you mean, no?
The level is at that point, right? So
Yeah,
we're
so
talking
all of
here
the
about
perpendiculars to that vertical, like you've just said, they would be parallel. So all of the perpendicular levels to that plumb bob, they would also all be parallel too.
yeah, but they don't remain level.
What?
So
the perpendiculars.
That's right. So level is perpendicular to a vertical, right? So if we take a plumb bob, a single plumb bob,
Level is perpendicular to both vertical and
wait,
plumb.
let me finish. So we take a plumb bob and we define a plane parallel to that plumb bob, like the one that's created by the little float in your auto level and a little whatever your auto level works. So we have this plane perpendicular to that vertical.
Did you just say
Okay.
however your auto level works? We're talking about
don't know
mathematics and perpendicularity, right?
Yeah. So, but we're also talking about real world, right?
Absolutely.
What a vertical is, what plumb is.
Yeah.
Right? Plumb's not a mathematical term; it's a real word term.
Mm-hmm.
So we take
Vertical.
that plumb line, which we cast a plane perpendicular to that plumb line. At the point of the plumb line, I'm happy to say that is level and horizontal.
The point of the plumb
We move
line.
out along the plane.
Where's the point of the plumb line?
Sorry?
Where's the point of the plumb line? Because that's what you said. That's where it is level. Where's the point of the plumb line?
Along the line of the plumb line.
The vertical.
Extended infinitely in either direction, right?
Yeah,
along that line, we can say that parallel plane, a perpendicular plane, at the point of the plumb line is both level and horizontal.
Mm-hmm.
As we move along that plane, we'll find
and all of the perpendiculars would be parallel.
No. Oh, the perpendiculars are parallel, but the verticals are. Right? Because that's the definition, right? That's like your proof.
No, we're
It's
talking
basically
about
saying parallel.
the vertical stays vertical, right? We're not bothered about. Don't move the vertical.
Right.
All of the perpendiculars to that vertical will be parallel.
Yes, that's right.
Okay, that's good.
But not all
we do have
verticals
an
will be
understanding.
perpendicular to that plane.
Okay. Well, what about if we were to have a perpendicular, like one of the perpendiculars to the vertical that you start off with, right? What about if we use one of those and say, could all of the perpendiculars to that be parallel also?
Yeah, well, that's right. Basic geometry, right?
Mm-hmm.
All perpendiculars to a line are parallel.
Yeah, like a grid formation,
so that's
right?
that's a
like
non-statement.
everybody knows.
Yeah.
Yeah, like a grid. Yeah.
So
that
here's
comes
where,
from perpendicularity, right?
So we need to get back to reality. We're talking about verticals
and perpendiculars,
and the plane's perpendicular to the verticals.
Mm-hmm.
Sorry, I'm puffing here, walking up the hill. So if we've taken our original vertical, we've got a plane based on that vertical. If we move along that plane and drop another plumb bob, over time or over distance, we'll find that plumb bob becomes increasingly.
Did you say time?
Out over distance, right?
Okay.
Over distance. See, you're so focused on words. But so over distance, we'll find that a new vertical reference to the original plane will be out of perpendicular.
Mm.
And we see that in two ways. One is that, we see it.
Nice.
You've even photographed it, but you'll deny it. So what we see as a consequence of that is that a level line follows an arc across.
But you said it was perpendicular.
It's at the point.
Yeah, but you
of
did
the
say
vertical.
it is. You said it was perpendicular.
Yeah, at the point, Bev. The word, you're so fixated on words, it's important you use all of them, right? Context matters. So at the vertical,
Yeah, the vertical.
the perpendicular
straight line.
is level.
And perpendicular
You could
is
even say at or
perpendicular.
near the vertical, right?
You do
At or near the vertical. So Mikey
Do you
Jones
know
is
what
happy with building
perpendicular
stuff.
is? Do you know? Have you ever? Yeah. Do you? Definition 10.
Yeah.
Do you want me to read it out for you?
No.
I'll get it and put it in the chat
I know
for
what
you.
perpendicular is, right?
Do you know the definition of perpendicular within mathematics?
Not
Because it would come in
off the
handy
top of
right
my head.
now, I would imagine.
Yeah, crosses at right angles or something, right? Yeah, I don't know what the technical definition is off the top of my head.
Technical
Doesn't really matter.
definition? No. This is
Because like you
This
said,
is the
we can have these
mathematics.
intuitive views.
Yeah, this
Right?
is
So like some of
the definitions
Euclid's
within
given that we just
mathematics.
accept. Right? So in my mind, I have that right. I don't need to know the formal definition of perpendicular because I just know what it is.
Okay, well, I'm going to read
But
it
anyway,
out
where are you
for
going
you.
with this?
I'm going to read it out for you, just so you know. This is definition 10, book 1, Euclid's Elements, right? It comes before the axioms and the postulates or any of the propositions. Definition 10. When a straight line standing on another straight line, that's 2 straight lines mentioned there, makes the adjacent angles equal to one another, each of the angles is called a right angle, and the straight line which stands on the other is called a perpendicular to it.
Perpendicular, good.
2 straight
Thank you.
lines,
We've
though,
got
right?
that sorted.
2 straight
Yeah,
lines.
so where are you going with this? Right?
Well,
we all understand what perpendicular is.
Perpendicular is a relationship of 2 straight lines. If
Yeah,
one of those
or a
straight
line
lines
and a
is
plane,
plumb, then the other one is level. The straight line that is perpendicular.
Yes.
That has this
Yep,
perpendicular relationship.
Yeah, but the term level is not a geometric term. It's a real world term, right?
Perpendicular is a geometric definition.
Yeah, but level is not. Level is a real word.
You used level as being perpendicular to vertical. You used the geometric term to link vertical and level together.
This conversation is about the real world. We stated that a few minutes ago.
Yeah,
Let's
we're talking
talk
about
the
straight
real world.
lines. The definition of straight.
So
and
we
you're
said,
using perpendicular, which is basically I would call that the proof of the straight line.
Proof of what straight line?
A
That
straight
level is a
line.
straight line.
No, a straight line.
Perpendicular is not proof of a straight line.
It is, because you can't have the adjacent angles equal to one another, both right angles. It makes 180 degrees, doesn't it? Or the sum of 2 right angles, like a triangle.
It doesn't define a straight line. I can draw a whole bunch of lines across each other at right angles.
All right angles are equal. That's an axiom that comes later, right? After the definitions.
So where are we going with this, Bev? How does this relate? So I've said that the real word term level at the point of the plumb line is perpendicular to the plumb line.
Level is
And
perpendicular.
you can draw a plane. You can draw a plane that is perpendicular at that point as well, right?
Well, perpendicular to a straight line would be a plane, wouldn't it?
Yes.
Yes. Okay, so you're saying level is a plane perpendicular to plumb.
The plumb line. No, I'm not saying level is a plane. No, I'm not.
You said it's
I'm saying
perpendicular.
At the point of intersection, it is perpendicular.
Yeah, perpendicular is a straight line.
But
level is not a straight line.
Why call it
is not a
perpendicular
plane.
then? So you're contradicting yourself.
No, it's a line that is perpendicular. It's not a straight line.
Yeah,
And
but perpendicular means 2 straight lines standing one
No,
on the
no.
other.
Perpendicular means crossing at right angles.
Yeah. How do you have a right angle with a curved? One of them is curved.
We've
You
been
can't
through
have
this
a right
100
angle.
times.
Well, apparently
You
you
know
didn't
how
get
to
it
do
right.
that, right? I think it even
but
says in Euclid's book that
perpendicular.
the
No,
Come
No,
on,
it
dude.
doesn't.
Well, it's
Let's
technically it's
not
probably the
turn it
tangent,
into
right?
a shit show.
Show me
Yeah.
Euclid's book where he has a straight line standing on a curved line and
Come
calls them
on,
perpendicular.
no. Look,
Yeah.
this is
When he's talking about the
self-evident.
tangents, right? I've
All
seen it.
right angles are equal. That's all four of them. When you
Yeah.
form perpendiculars, then all of the four right angles would be equal. The only possible way that could happen is with straight lines.
No,
Yes.
no. We can talk about
It's
if you want to get down
self-evident.
to the micro level, right? As two lines intersect, you can consider them as straight lines at the point of intersection, right?
Don't be stupid.
This is some of the new maths, Bev. But anyway,
New
No,
maths.
hang on, Darren. Darren, a point is not a line.
no, at the
Even
point, right?
even in your spherical geometry, a point is not a line.
No,
You keep
exactly.
wanting to make a point a line.
No. You can
Yes, you do.
you can talk about so whereabouts on those two straight lines that intersect, whereabouts is the intersection? Where is the intersection of those two straight
The
lines?
intersection
Yes.
of the line. Yes.
Yeah.
Is a
So
point.
why can't that apply to any other arbitrary curve? To any lines, they don't have to be straight, can intersect at a point, right?
But perpendicular is two straight lines.
No, perpendicular is two lines at right angles.
Yes, and angle is a section of a circle. So you have, in order to measure angle, even conceptually, you need to have distance called radius to make.
So this is going to go nowhere. So we'll stop that section. We'll go back to where we were, right? Because this goes the same way it always goes with you guys, that you can't conceptualize intersections of curves. We'll go back to our definition of level, right? And how at the point of plumb, it is perpendicular to the plumb line. What we're saying, or what our key difference here is, going back to what was flat Earth, Bev, is that if you actually look at those verticals and plumbs in reference to the original plane that you create, you'll find that the verticals are no longer perpendicular to that original plane.
Is that new maths?
No, that's real world.
Okay.
So where did you
that's the
find
thing, right?
it?
That's the key difference between what I see in reality, what I see in your photo of the Black Ball Tower, what I see in the auto level shots pointing out over the sea, is that the horizontal at the point there is no longer the same at the point where you're standing, right? So where your auto level is, or where you're looking, that the horizontal there is
point
clearly divergent from the horizontal
point
as things get towards the horizon. So your horizontal at Blackpool intersected the tower 12 meters above your elevation. How can that be if the two planes are parallel? It cannot be. Either something wrong with your instrument or
No,
something
just
wrong.
perspective. It's
No, you know this full well, paper, that perspective does not alter the relative position of things along the focal line of the lens.
Was the
Yes, it
auto
does.
level level? Like, was it set up correctly?
Yeah, well, that's an excellent question. If you didn't set it up correctly, then I'm prepared to say that we can't use that image as a reference. It appeared to be set up level.
So you don't know.
You seem to take great care. Take great care of your instrument. You know how to use it. I have no reason to
Did
believe.
you see anybody setting the instrument up?
No, I didn't, Bev.
Okay.
So I'm happy to say if your auto level was pointing 1 degree off horizontal, then that's cool. We can say that image is no good. And it probably means that those initial readings you did, where you showed that the beach was approximately level, are also completely out of whack. So
no, that was
all
we were doing was an optics test to show people what they could see over 500 meters. That's the only purpose we went there. Yeah.
But can you put your hand on your heart and say that your auto level was out of whack?
I'd say
so that it would be 10 meters.
It could have been set up, but I don't know. I can't remember because we were just doing an optic test. If you can remember when we actually did the YouTube. We broadcast it to Discord. Sorry, that's where you'd have got your footage from, yeah.
No, I got it off. I don't know. It might have been
Some old
Blue's
dude, some
video, I'm not sure.
weird dude.
Yeah,
gave you a picture.
Yeah, there's a lot of old weird dudes in this arena. I can tell you.
I know.
I'm probably one of them, to be honest. But anyway, my time's up. I have to go today.
Okay. Well, thanks a lot.
Interesting to talk with you, but I didn't want you to go slagging me off, calling me a liar without some kind of.
Why would I do
defense.
that unless you think somebody not believing?
You've called me a
you.
liar before, Bev. You've called me a liar on these streams before.
No, I haven't.
Yeah.
I don't do that.
You have. You have.
I've said I don't believe you. I mean, I don't believe you that you can think that
you've
straight is
I
different.
am lying, trying to deceive you. But anyway, I've got to go. Have a good day, guys.
All right.
Be nice.
So
you've heard it from Darren's mouth there of himself. Darren's vouched for himself, and don't you? Well, you can judge for yourself what you think, but he'll consider you thinking he's a liar if you don't believe him. We go back to the.
I think he's a sophist.
I think he's definitely a sophist. Well, I know he's a sophist, to be honest.
Yeah, he struggled badly.
Well, we've not even got into the meat of his straight, because it was like, I don't know whether you call that the initial first bit. It's a bit of foreplay. They always disappear when it gets to the good stuff. He didn't the other day. He stayed for a little bit longer than he should have done.
Always seem to stop at level is horizontal at the point, and then try to claim that perpendicularity occurs and is a real thing in reality in our world, but completely ignore the fact that they're claiming that level is curved and they're getting perpendicular to a curve that doesn't exist, that can't exist. But that's not lying. That's sophistry, apparently. I'm okay with that.
Well, like I say, I don't particularly call them liars, because as we went over with KC, they're going to call you whatever, and they're going to imagine anything of you, whatever. It doesn't really matter. Yeah, they can either disagree with you and call you a liar, or they can say that you don't believe them whenever they're saying anything. Doesn't matter what they say, you have to believe it, otherwise then you'll be calling them a liar. It's a bit hypocritical, really. And they said I did this one today.
I do appreciate Darren coming in though consistently.
Yeah.
Hopefully he'll be back tomorrow for All Friday.
Yeah, we were saying that it's pretty obvious, I think, that Darren is a minder for Wally. Because they have opened up this stolen concept. Wally's been around here, sniffing around here for 2 years. He came with the Dave Weiss Bitcoin Challenge with a stolen concept. He reimagined what I'd seen from Jesse Kozlowski and the guy that may or may not live in Maine. But they ran away, so you can never talk to them about it. So then Wally brings up an argument, which we may or may not get to because it's ridiculous. He did that, came here, got really triggered for a year. I kept saying to him, come and have a conversation and we'll have a go over the stolen concept that you've got built into your argument. He didn't. He took it to Nathan Oakley. Nathan Oakley didn't spot it either, or they just let it pass. One or the other. I don't know.
I'd like to know what people...
Go on.
Oh, go ahead. No, finish up.
I see. And then now he's passed that on to Blue Marble Science, who's made a video doing a very similar thing. And as we pointed out with the main surveyor, he's also done the very similar thing. And it's all based around this straight line, 180 degrees, triangle. And I don't know. They're not wanting to go beyond the straight line further than the point, because for them to have the perpendicularity at a point is them reducing half of the perpendicular relationship to a point.
Exactly.
That's the
Yeah,
stolen concept. Sorry, go on.
It is. I was just gonna say I would like to, if Darren comes back, I would like some details on how he sees it. He mentioned a photograph. I don't know what photograph he's talking about. Whether he thinks he's talking about your not photograph but video with Blackpool Tower in the background, or if he's talking about some other image where he sees that level, that verticals aren't parallel anymore, or that level is not horizontal beyond a point, or any of that kind of stuff. It'd be great to see it, because as we saw in Casey's video yesterday, that's a difficult proposition when you're talking about optical drop, and it can happen in someone's backyard in within a couple of feet.
Yeah.
It always occurs.
Yes,
Not
indeed.
always. This is just normal behavior, let's say, of optics.
So somehow optics is greater than Euclidean geometry proofs.
I think so, yeah.
Right.
When we did the divided line and we saw that the mathematical objects are above the visible and images are the lowest of the low, well, yeah, that's what they've done. They've
flipped it,
completely inverted it and put
upside down.
Yeah.
Yeah. Isn't that interesting?
Yeah.
That's a great point. That's a great point.
You cannot just apply geometrical, let's say, laws or principles just to the picture, because it involves lensing. So in geometry, there is no lens there, but we can see through the lens only, and camera also can see through the lens, everywhere lens. And you just cannot ignore that looking at the picture. You cannot just make a geometrical statement looking at the picture, because you need to take into consideration these optical effects, which occurs always.
But on the divided line, it is just in the realm of images and imagination.
Yes.
So, like, you're never going to get beyond that. You can't get to the... because you can't even get past the trust part into the actual mathematical idea of being able to mathematicalize it.
Right. And actually, if anyone wants to play this back, or you listen back to it at some point, you'll hear Darren say toward the end, well, this is not going to go anywhere. We're going to go to the same place because you guys can't conceptualize. That's what Bev's talking about. If you've been with us in the Discord for the Western philosophy classes and you've understood what the divided line is, that conceptualize or imagery or imagination is at the very bottom of what's deemed reality. It's the lowest possible form of, quote, reality, unquote. But yet that's what Darren wants us to do, conceptualize. Well, you guys just can't conceptualize.
You can't imagine it.
Right.
And you cannot draw it, because normally we can our concepts draw on piece of paper, like Euclid did. He had concept and he drew it on piece of paper or papyrus or whatever. So you can make a picture of your thought, but you cannot make picture of thought that is illogical. or incorrect or just fantasy. If it doesn't match reality, you cannot draw it. It is impossible.
Exactly.
And by the way, this point, horizontal point, is just nonsense because there is no relationship between point. This point is also vertical, so it lies on vertical line also, this point of intersection. So there is no relationship of perpendicularity at the point, as they say.
We
This
did
is
say
just-
that both of the plumb vertical have perpendiculars, horizontal and level. They're both perpendicular, but one of them is a different perpendicular, despite the fact that there is no definition of perpendicular that's different. There's only a mind conceptual thing that Darren has, obviously, that separates these things that are the same from one into the that and one into the not that.
Yes, but impossibility of Darren's thinking is that you cannot establish, measure, or check perpendicularity at a point. You need a line, because as I was starting to say, but he just went out, that you need a circle, because angle, to measure that these angles are equal, you need a circle, because we can measure angle only by means of circle, and circle has a radius. So you cannot make radius at a point, because radius has to have length. It has to be outside of this point of intersection to measure angle and to check that these angles are equal. We need a circle, we need a radius. Not possible within this point of intersection. Not possible.
It's the idea of the straight line, isn't it? That he's trying to reformulate in his own mind.
Yes, so if you said that, yes, he is reducing this horizontal line or level line, whatever, to the point, it means that he cannot say anything about relationship between plumb bob and level, or vertical and horizontal. He just cannot.
Yeah, he's what he's doing is he's reducing it to an absurdity by self-refuting the line that he's starting off with.
Yes, if he is reducing line to a point, then he cannot do anything with that. So he cannot say that they are perpendicular even. He cannot say that.
Yeah, because he only has one line.
Yes.
With no other line to have the perpendicular relationship to.
Yes, and reducing one line to the point which lies within another line, it means that he has only one line.
The vertical.
Yes, vertical, yes.
So that's what he's doing with the straight line. So he's got the vertical as being the straight line, but then the other straight line that he can't admit to himself that isn't a straight line. He has reduced it to a point to reduce the argument around it, and then he can just disappear. Come back again tomorrow as though he's had the argument and won it.
That is exactly what's going to happen, I predict. We'll see. But
yeah.
Thanks again for coming, Darren. This two great days in a row.
It's straight. I'm pretty sure I said the other day, Darren's entered an arena where I think the most discussion about straight has ever gone on. I've had discussions for hours about straight, Particularly, it starts off whenever you try and take somebody through the 12 steps. Highly model afflicted. It depends on how model afflicted they are as how far you can get. And the more model afflicted they are, the longer you take on the straight line. People can't come to terms on straight. I've got the feeling that Darren's going to be one of those.
Yeah, it is amazing that in 2023 we have to that one could even have a conversation about straight for hours, or need to. But here we are.
Can we carry on with the straight thing? Because it gets even better. Darren opens up to exactly what's going on in the mind of the, I don't know, straight denier? I don't know what to call it. It's a really weird concept, this. I'm not so sure even people realise how big this is within the arena, the shape arena.
It's a straight point.
It's a contradiction in terms, oxymoron.
Yes, and straight line is that.
It felt dumb saying it, trust me.
Straight line is that lies evenly between extremities, and definition of the line is that in definition of the line we have that extremity of a line is a point. So
you can't have the point being both extremities.
Yes, two extremities. Skeptical wanted to say something, maybe?
Yeah, I just have a question. So is straight line a mathematical term, or is it?
Yes, it is.
So
Yes.
can we say that a straight line is a mathematical expression?
Yes, this is mathematical term. Even sometimes it is called just straight. For example, in Polish, mathematical term for straight line is straight. Just one word.
About the number one.
Straight. What about number one?
It's a straight line.
It depends, doesn't it? I don't know how you view one as a straight line. Would be a unit.
Well, I can say that I've never drawn a C and called it a number one. Just saying.
I suppose you've got a point there.
Yeah, that's just being a little pedantic, I guess, but technically the first number is in line.
Wow.
And zero is a circle. Ones and zeros. It's all about ones and zeros.
Can we carry on with this expose of straight then?
Please.
No. He didn't have some of the tools. So some of the things that he said were givens, we have mathematical definitions for now, like straightness. And he just described it, but he didn't have a mathematical formulation that he could use to show it.
Really? Euclid didn't have a mathematical way to show straightness that we have. Modern day mathematics have an extra way.
No, definitions are part of mathematics. And he gave us definition. So he did what he should and knew, because Darren was talking about calculus. Calculus is, if calculus is redefining line or straight line, then it just changes definition of straight line. So we are operating in two different definitions then.
Yeah, but you can't really redefine straightness into something else. It's not like the mathematical understanding of straight doesn't come from somebody writing it down. The mathematical realm is that realm of thought. So I don't think you could get somebody to actually redefine straightness or even define it.
Bev, okay, are you saying that basically we can't come up with a mathematical formula for a straight line?
Well, if you were to use X's and Y's, then you've already defined the straightness into the graph that you're going to use to help you define through mathematically numbering with an X's and Y's. Whereas Euclid defined the straight line as part of an axiomatic system.
Yes. So if Darren was talking about formulas like calculus, so definition of the straight line is already there because it is definitional. So I don't know what they did in calculus, and I don't care, but still their basis is still definition of straight line. Euclid definition, of course.
Yeah, this Euclid is the basic understanding of mathematics, like through logical thought, from the conception of a point. You can't. There's no way that you can actually go back and bend that straight line mathematically and start again with a different mathematical system, because it's not just geometry you're messing about with. You're messing about with the unit circle and everything. The unit, you're messing about with one, like Rob says. It's a straight line. You can't change it. Even definitionally, it wouldn't matter to mathematics. The law of identity and the law of non-contradiction and the law of the excluded middle goes through mathematics, or it did up until modern, which is what Darren's teaching us about. Not too sure people like Darren should be qualified to be teaching this new modern mathematics. And they really seem to have. I've had it for like 4 years, people teaching me modern mathematics. They have a very strange technique of trying to get you to, I don't know, repeat, parrot what they say. I don't know.
I cannot believe that this modern mathematics is mathematics, because you can learn mathematics using proofs and arguments, definitions, axioms, etc. And this is okay. You can understand everything. But if someone is using dialectical proofs or sophistry, it definitely cannot be mathematics.
I would agree. But that's because of the journey I've been on has led me to first principles rather than stick. I don't know what to call it. rather than going up the ladder, right? We've gone down to make sure that the base and the foundations are all there. So that's where my understanding of mathematics comes from. Actually, there is a course that we will be going over from Hillsdale College that goes over Euclid and shows you the underpinning of mathematics that was and still is Euclidean geometry. I'm hoping to do a big series on that. I quite like the idea of that, going over the logic and the foundations that comes before Euclid that leads to the formulation of mathematical, and then the development into modern day mathematics and modern day logic, modern day geometry, and modern day logic, modern day thought. It all seems a bit sophisticated.
Yes, I would say that modern logic differs from old logic, and modern geometry differs from old geometry in one way. It is just twisted old logic, twisted old geometry. That's all it is, this modern whatever.
Yeah. Well, I think what we should do is, rather than differentiate with like old and antiquated and all of that sort of stuff, I think we should differentiate them with the modern day straight as opposed to just straight.
Yes, twisted straight. Because of course it is curved. So normally we should say that it is curved. So this is twisted straight line. So now twisted straight line is straight line. Twisted logic is logic. Twisted geometry is geometry.
Or can be considered as such. I like the way that Darren, with little to no understanding, as he's told us, he doesn't know anything about spherical geometry, doesn't know anything about Euclidean geometry, but he's willing to say that Euclid didn't have the mathematical tools that he has today. Not realizing that a mathematical tool is only in your brain. That's the only place it exists. It's within the realm of thoughts, mathematical objects.
Yes, by the way, calculus is just sounds like calculator. So, and by the way, in ancient times they used calculators, not electronical though, but they were calculators back in the day, but mechanical. But so they had calculators, they had tools, but they didn't need them for formulation of axioms, for formulating proofs, etc. Because calculator is just useless.
Are we ready to carry on? He's telling us about Euclid.
To show it.
Really?
And yeah.
Okay. So what's the new mathematical definition of a straight that you?
So a straight line is probably defined as something.
Probably.
Wait.
Is that the mathematical? Does that start off? The mathematical definition of straight starts off with probably.
No.
So. He did. He said the new mathematical definition is probably. So we're going to get it now.
I just want to jump in here and say I don't think you're doing too well here, guy.
Well, this is an introduction to Western philosophy.
Yeah, I know.
Okay.
And
So you're
yeah, but you just
representing
picked an example of specific interest
the
to me,
counter
right?
to logic, are you?
So okay, I'll abandon this then, and I'll ask you a question. What is the argument type? Because I'm not a philosophy guru. When you
He's not a philosophy guru. Does anyone want to take him on that? Do you want to believe him or not? He doesn't know what the argument is. He's not a philosophy guru, says Darren.
choose to use, say this scenario we've got here of the definition of straight, and how just the word, is used in two different scenarios with two different meanings. But you then
see, literally,
just the word is used in two different scenarios with two different meanings.
Just the word is used in two different scenarios with two different meanings. He's trying to slip that past you. You've got to be really careful when you're dealing with sophists. Because if you don't pull him up on that, he's going to imagine you're agreeing with him. They don't half work in strange ways. Just the word has got two different meanings, two different scenarios.
No, you cannot, even if you have two different, let's say, geometries, still you have two different words for straight and for curve or arc. So it is not still justified to name curved line a straight line just because we are in different geometry. No, it is not justified.
Yeah, same word. Same word.
Also, can I just add that?
Go on.
Just picked up on just the amount of times that he says either we. Yeah, he says that quite a bit. And right after not every, but a lot of what he says. And obviously, as we know, that's if no one sort of says pulls him up on that, then he's obviously taking that away as an agreement.
Yeah. Yeah, he's giving you your confirmation, and you have to take that away from him. Otherwise, he's going to accept it as your confirmation. Listen to his words, though.
Is used in two different scenarios with two different meanings. But you then...
Oh, sorry
two
to put in...
scenarios. Sorry, go on, Gadget.
Can you hear me? I know, yeah. I just put a new setup in my Discord. Sorry, go ahead, Bev. I'll come in back in a sec. Okay, sorry.
Okay. And take those two different meanings and make them one, and they're contradictory. What is that called in philosophy? When you take two things that aren't the same.
Look,
maybe I can come in now,
go
just for a second. Sleep. Do you know where the ballers say the tangent is the horizon? That's what they say, right?
I don't know. They've never said that.
Local horizontal. And people are saying that the tangent is the horizon.
No, sometimes they say that horizontal is tangent to the surface.
Local.
Yes, local, and they reduce this horizontal to the point.
I think it was Nathan Oakley that put the tangent over there. I never understood that, but I think that was Nathan Oakley that placed the tangent.
Yeah. Because my best friend, he's a pilot for Air France, and I go flying with him. I used to go flying with him about 3 years. Now he has his license, but 2 or 3 years ago, just before takeoff, you used to cage your horizontal level to the runway, okay, and then I don't know how long a runway would be, but that would be your attitude meter. If you were level and horizontal, I know your nose would be up, but you used to cage your machine, the airplane. You cage that, so then you take off, and you know your exactly your attitude as to your space and time. I wouldn't,
What we're dealing
So
with
we,
here, though, Gadget, is we're dealing with the first principles of the understanding of what straight is.
yes, exactly. So my runway, like the runway, would be a big runway, or for a little plane, you take off 500 meters, but your attitude meter would be straight and level before you take off, and would be, your attitude. With a big plane, where he's flying now, the runway would be what, 2 kilometers long, 1.5 kilometers long. He's flying the big planes now. So what they're saying is local horizontal. Would the attitude of the airplane change in a kilometer on the runway?
We're dealing with straight.
Yeah, straight and level, yeah. Because the nose of the plane has to. I don't know. It's not much. It's 2 or 3 degrees or 5 degrees or something like that. For flight. Get the air under the wings, but your attitude meter, your level, that little thing with the horizontal. It's like a little bubble. You see the wings going left and right, up and down. That's your attitude meter. That's set. In attitude. Yeah, I can't remember what it's called.
I don't want to upset you, but I don't know what this has got to do with straight and Darren's problem. Other than the fact.
Oh, sorry about that. Just give it say hello. Thank you.
Yeah. We was talking about level because it was perpendicular, with the geometric understanding of straightness around the perpendicular. I don't think we need to take it into. I don't even know what sort of an argument that the aeroplane thing is.
Straight level, like before taking off on the plane, babe. That's all I want to say. You have to have your attitude. You have to know where you are. Straight and level, in flight, on the ground, and in the air. You have to have your attitude meter. It's like walking down the street. Your brain say you're straight and level. You're not walking sideways. It's your ears that does that. Your ears tell you that you're straight and level when you're walking down the street. And when you're in an airplane, you have to set the attitude meter, the gyro compass, to say you're straight and level while flying. And I don't know. It just doesn't work on it only works on a level plane. That's all I wanted to say. Sorry to cut in.
No problem. Carry on for a bit.
Is used in 2 different scenarios with 2 different meanings, but you then take those 2 different meanings and make them one, and they're contradictory. What is that called in philosophy? When you take 2 things that aren't the same, make them the same, and use that as your absurdity.
I think he's lost within a logical conundrum. He's obviously struggling because he's introduced a contradiction, but now he's trying to struggle to justify a contradiction that he's made himself, even around the wordage of it. And he wants either you or me to give him the word of what he's got within his own mind. Do you want to listen to it again? Because it was It was a bit interrupted, so listen to what he's trying to justify to himself.
Is used in two different scenarios with two different meanings, but you then take those two different meanings and make them one, and they're contradictory. What is that called in philosophy? When you take two things that aren't the same, make them the same, and use that as your absurdity. Is there something in philosophy that talks about that? I'm not familiar enough.
Yeah. How messed up is he?
Yes, he's just breaking law of identity. So you cannot make two different things as one. You cannot. So.
Yeah. But he thinks that's what we've done when we're saying you can't have straight being straight and not straight. He's trying to pass it on to us as though it's our problem, because he's obviously not wrong within his exploded logical system or whatever.
Yes, this is not our problem. This is problem with logic. So if someone is stating something like that, is in error. This is logical error. Simple.
He's taken on a paralogism and is unable to question it. He doesn't know where he's got it from or however it's in there, locked in.
Yes, right? Yes, because if you are saying that,
that's you.
This, let's say, Euclidean straight line is the same as spherical straight line, which is not.
When they're not.
It is absurd.
Yeah.
It is absurd because they have
No, you missed my point, paper. So if you say a Euclidean straight line and a spherical straight line are the same and they're not, that is an absurdity. But what is it when you say that a Euclidean straight line is the same as a spherical straight line when that is not what is meant?
This is called contradiction in terms.
Because so we have a contradiction in terms here, right? That the terms used in spherical geometry are not the same terms used in Euclidean geometry.
He doesn't understand geometry, does he? Doesn't understand how basic in nature it is and how fundamental it is to mathematics. That straight is straight.
Yes, it cannot be changed in mathematics or in geometry, because if we say geometry, and even if it is spherical geometry, it still is supposed to be geometry. So principles should remain the same.
Yeah, I think it's the geo part, right? Like reality. This is reality geometry, therefore it's on the real globe. So you can't separate the two. Reality and geometry are linked together. You can't suddenly say, well, we'll have a different geometry, and where's it going to be placed? Because geometry is reality. It's in reality already. There's already a geometry that exists. Can't replace it. Or can you? I mean, who doesn't trust themselves enough to understand that they know what a straight line is, what straight is, conceptually? Are you going to be that weak that somebody can tell you that straight is different within another conceptual thing? So that means that you have to acquire straightness in as a different thing as well as what straight is. I mean, at worst, they're trying to capitulate you into violating the law of non-contradiction or adding a middle term in. It can't really be adding a middle in. It's got to be violating the law of non-contradiction and the law of identity.
Yes, yes, they are. Straight, not straight. And for word not straight, we have curve or arc or whatever else, or great circle. But still it is straight or not straight. So this is contradiction in terms, because you cannot be and not be at the same time in the same regard. So and this professor said that this in the same respect or in same regard. So we have this line being straight and not straight, and this is same regard. So we are saying that straight is straight and not straight at the same time. So it is impossibility.
About modern philosophy, though, right? Do you reckon there's a chance that they might have just allowed that?
I don't know. Maybe, but this is not science anymore.
Yeah, I'm gonna do Globjek. I'm struggling for the identity one though, but the included middle. The law of the included middle. Yeah. And the law of contradiction. That's they're obvious ones, right? Hardly noticeable to anybody.
Okay, but also law of insufficient cause.
Yeah. Yeah, they're all easy, but the identity one's a bit of a struggle.
Because it is already invented.
Yeah, sophisticated laws.
By this Heidegger or Heisenberg or whoever, this rule of uncertainty in modern physics.
Yeah.
So we cannot identify what it is because we cannot be certain.
The law of non-identifiability.
Yes. So it already is.
Yeah. I like it. I'll have to remember those. Yep. Right. Well, this is what he's doing. He's formulating a new thing, and at least we can learn from it.
Even though the words are the same, the terms don't have the same meaning.
Hang on, sir.
Yes.
Can I just...
Even though the words are the same, the terms don't have the same meaning.
Hey, why'd you cut me off?
Okay, sorry, can you stop for a moment? We have situation where word is the same but has a different meaning, like ball. Ball is like a globe, or ball, this is place where we can dance. So there are completely different meanings, and word is
No, hang on, paper. That ball is not a place; it's an event.
Okay, event, whatever. But this is, I'm saying that this is completely different meaning, and the word is utterly the same. But we know that, and we couldn't use that in different meaning, because if we in science can say something about ball, we know that only one meaning is used in, let's say, geometry. If someone is using the word ball in geometry, he's not using, obviously, that this is an event, dancing party or whatever.
Perfect, paper. Perfect.
Here we go.
Hang on. Sorry.
Oh, there we go. It's Rob. Sorry.
Rob,
Sorry, Rob. I cut you off again twice.
Hang on, sir.
Yes.
Can I just hang on. Sorry, paper. Excuse me, sir. Do you know that sphere
I'm gonna start cutting all of these things out again. You could have paper agreeing with you all the time. You could Rob interrupting. I could play that again, couldn't I? Listen. I get a ringtone of Rob.
Hang on, sir.
Yes.
Can I just hang on? Sorry, paper. Excuse me, sir. Do you know that spherical geometry is purely a 2D representation of a 3D object?
A spherical geometry.
After hearing that, Rob, I get the impression that you're like chasing somebody. Excuse me, sir. Excuse me, sir.
A spherical geometry is a three-dimensional.
No. Maybe you need to Google.
You should have let him go with that as well, Rob. Shouldn't be so keen to correct them. Show him how much you know over him. You should have let him roll with it. See where it developed into.
Spherical geometry again. Sorry, sir. You're wrong.
It's describing shapes on spheres. Spheres are a three-dimensional space.
He's actually right, Darren. If you look it up, that the definition of spherical geometry is conceptual 2D surface of the 2D geometry of the sphere, which is, I would say, contradiction also.
You could have, I think you could have played in there for the square, because he said it's about shapes on spheres. You should have asked him, what shapes? A square? How many sides?
You might have got the square
Spherical.
You might have got the squarical axis.
Yeah.
You forget.
Yeah, it's because you're so keen, isn't it? You know, you get in the flow.
It's been so long since somebody's brought that stuff up. You just forget about like all of the nuances that have happened over all of the conversations where people, are you saying spherical geometry doesn't exist?
I would say that we have new complication with that because on a sphere we have spherical triangles and spherical squares, but what about spherical spheres on the surface of the sphere?
Is
Because
it not a sphere?
on the plane we could have a planar sphere.
Yeah.
Weird, but okay. But on the surface of the sphere we have spherical sphere. Great.
We're playing it all, Darren. All of this is this whole bit where you came in with the straight line. Because that's what we're going over. This is a Euclid night. There's nothing more basic than a straight line. And since we are talking about reality, then that's the relation this has to reality. The geometry, it's how we describe reality. Euclid is the king of infinite space. Got a book. At least he was up until modern times, and I quite like the old traditional, but I don't know why you call it a traditional. Sorry, go on.
Up until new maths.
Yeah.
Whatever that is.
Yeah. Well, people on Discord come round and tell us. Apparently lots of people have told me about this new maths and I've just not accepted it because to me it sounded like a load of bullshit. Redefining straight.
Yes,
The sphere itself is a...
Go on, sorry. Was that you or...
No, this is clip.
3D space, right? And we're talking about
I think you need to Google your logic a little better.
Yeah, so I get where you're coming from there.
Yeah, what you're thinking of there is you're thinking of the Euclidean sphere. That's
Exactly.
the 3D one. That's why I was talking about the stolen concepts. You're actually using a Euclidean sphere.
Look, I won't distract your conversation about philosophy anymore. I just was interested in the use.
Well,
the
it was.
misuse of the
It
term
was.
straight.
Thank you. It definitely helped because what we're talking about is the law of identity, and we're talking about the identity of the Euclidean sphere. That's what you were using. That very sphere.
Yes. Yeah.
Yes. But you were also trying to say it was not Euclidean. You were trying to change a straight line by using the Euclidean sphere, which you had to use the straight line in order to make. But so there you're going back. You're stealing the concept of a straight line to say that the straight line is different than what it was to make the original sphere that you're dealing with, the three-dimensional sphere, like you say.
Yes.
Yeah, I
straight line
disagree
is
with that.
straight line is requirement for a sphere. And
Yes.
because it is a revolution semi circle along diameter. So this diameter is straight line, normal straight line. So this is like inversed inferring. You cannot have something in place of straight line which already exists, because this real diameter already exists, and then you are trying to replace this real straight line with something which you produced afterward. This is
it's just a mathematical transformation, right?
I think there again, Paper, you perhaps left that a little bit too long, because after all of that stuff that you said, after all the stuff that I said, all he has to say is it's a mathematical transformation. He's lost. He's been lost, hasn't he?
Pseudoscientific gibberish.
Yeah.
So what? Transformation. What does it mean? Transformation. Transformation. Trans, it means through, and form means formula. So shape. So
I think a little bit earlier though, he was actually in aporia. He didn't know how to react.
Yes, but still, transformation means that we are changing meaning of the world. This is real transformation.
It's a mathematical transformation. He thinks he can get away with it by saying it's within maths that he's transforming it. But that would apply to the law of identity, that it's changing from the identity of one thing into something else. It has to, in order to transform. It can't stay the same thing whilst transforming mathematically. Be zero change.
Yes, it is impossible. Yes. To be two things at the same time.
Breaking the laws of mathematics whilst using mathematical words to sophisticatedly take control of. I think what he assumes is that we're stupid, right? We're not going to notice this stuff, or perhaps he doesn't even know that he's doing it. I find that hard to believe, really.
Maybe because he was just staggering and struggling what to say, because there is no response for that. Because previously we have diameter to produce a sphere, and then we have no diameter anymore. So because we have no straight lines. So this is just mission impossible.
It's
Yeah, so we're not dealing with reality.
But at the same time, you are destroying real straight line. But
no, not.
Yes, you are.
You can't.
You are destroying bases on which you produced this sphere, and
there again. Did you hear that? He did the little sigh, and normally that's at the time I think you should let him answer.
Maybe, okay.
Yeah.
Yes. Then you are producing new straight line, but before you used a normal straight line. This is
Yeah, but
just...
we're not abandoning the concept of a normal straight line. We're just saying that on the surface of the sphere, we have these lines that we call straight. They're not the same. Everybody knows they're not the same. They don't have the same properties.
See, he says everybody knows they're not the same. Well, they don't. That's a massive assumption that he thinks he can use the same word for something different, and everybody knows that they're not any different. Like, that's really bad.
Yes, it is bad because we had conversation about straight lines, for example, with Rumpus. And he was referring to definition that straight line is the shortest distance between 2 points. So, and he insisted that this shortest distance on a sphere is curved. But because it is shortest distance on the sphere, and you cannot have shorter, it means that it is straight line. This is circular reasoning, of course, but this is Rumpus's argumentation. At least he tried to reason something badly, but still he tried. But Darren is just saying that this is just renaming, just because someone likes to do that. So there is no justification for that.
Yeah, it's definitional entirely. Which, yeah. I think it's perhaps deceitful, but who knows how deep the Tis Globe goes. Might just be a case of it has to be.
But we just call them straight for convenience and for comfort and similarity when we go to do our geometry.
That would be without
for comfort.
Psychological reason. Yeah.
When they go to do our geometry, right? Well, the only geometry that you can actually do is Euclidean. They use sine and cosine. It's Euclidean geometry.
Without purpose, because they are already called curved lines.
Yeah, that's the whole point of the stolen concept. You can't say when we go to do our geometry, whilst using geometry to form the sphere, to try and get rid of that geometry that you've used to form the sphere in the first place. Can you not see the stolen concept within it?
You said, Darren,
We're stealing the term. We're stealing the term, but that doesn't invalidate the mathematics of...
It's the he thinks it's stealing the term.
Yes, so he's changing meaning of the word, and he said that before. Yes, we can say that this is stealing concept or stealing word or hijacking.
He thinks it's just stealing the name, though, doesn't he? Simple as that. They're just stealing the name straight. The fact that we redefine it within something different and imagine it differently. He thinks that's what the stolen concept is. He doesn't need to look at actually at how drastic the stolen concept is.
No, it's changing meaning. It means that it is superposing. Like, for example, if we have a real picture of Picasso and falsificate. So this is just falsification. Because people will think still that straight, it is normal straight line. Because why not? It was never explained by any geometrician, global geometrician, that this straight line is different, that this is a curved line. No, they always insist that this is straight line. Even Rumpus did. And at Blue Marble Sciences, they established that straight lines are straight and curved lines are not straight. So I don't know why Darren.
I think you might be missing what my point is. I'm just going to go back a bit here. Listen, form the sphere in the first place. Can you not see the stolen concept within it? Right. So I've just gone over how this thing is a stolen concept. Right. The whole idea of what the stolen concept is. I've gone over that, where he needs a straight line to form the geometry, then he gets the sphere, then he brings the sphere back into the beginning, and he says at that point, well, straight is now different because it's on here. The whole idea of a stolen concept is the fact that he's using the concept of straight to refute the concept of straight. That's the idea of right. But listen to what he thinks the stolen concept is. He thinks it's just the term. He doesn't see the idea of how fallacious the actual idea of the stolen concept is. He thinks it's literally just stealing the term. Listen.
You said, Darren, that
stealing the term. We're stealing the term, but that doesn't invalidate the.
See, it's just stealing the term. We had Wally here, and we tried to explain it to him, the stolen concept, to get him to come in, and then we can discuss the idea or the concept of how you steal a concept, the self-refuting claim through logic. But I think these guys are misologists. Drastically. They can't understand how the logical argument works and the structure of the reasoning process behind all of this. I think that goes back to Wally. Darren and Wally are looking very close. Very, very close at the minute.
Mathematics of
it's the initial law of identity of this straight line. You are stealing and you're violating the very identity of your first principle that you start off with.
So what if we don't use the term straight line in spherical geometry and every time?
Yeah.
So he thinks he can get away with just saying, what if we don't use the term straight? Not realizing it's the entire concept of straight, not just the word, the term.
Yes, and by the way, they use name straight line, which is not straight. The whole thing is to, I would say, to deceive, but okay, to change meaning of the word in that way that people will not notice that the meaning of the word is already changed.
Yeah, so it's the entire concept. They're trying to warp your mind to make you think that straight isn't straight. At the minute, they may just be able to do it through wordplay and say that it's just the words and all of that. But actually, in the background, it's the entire concept of straight.
Yes, it is bending straight line, the process of bending of straight line. But they are hiding this process. They are only showing end product of bending straight line. And there we go. We have bendy straight line on the surface of the sphere, but they don't show how they achieve this bendy straight line. They don't show that they had to use previously normal straight line, and they are afterwards, they are bending it. After using normal straight line, they are bending on this spherical geometry. So this is, I would say that this is deceiving.
Yeah, I think I'm gonna redo that meme and put straight and straight with the miracle occurring in between, conceptual bending of straight. They have to work for a long time, and it's my opinion that these guys are testing this out on us, seeing how far they can push it.
Yes, yes. Or how dumb we are or not. So
yeah,
what shit they can sell.
Yeah, I'd say they're really bad sophists, but I don't think that they care. They're practicing sophists, so they're expected to get a lot of losses.
Yes,
every time we
that's
do
why,
a great circle, right?
this is
When
what
we say
I called,
circle,
you called it previously arc. You said that
Yeah,
this
an
is
arc.
arc. So in really, these new straight lines are arcs. And there is name for this, arc or curve.
Yes, yeah. Exactly. And we can use those terms, but it's like anything in
No,
maths
that's
and science.
Euclidean.
That's why I brought up pi, was because you're saying mathematics, but pi is a constant in mathematics, and you're talking about spherical geometry where that changes because you've got
Yeah.
contradictory terms.
Yeah. And this is where I don't like the terms in spherical geometry, right? Because of this apparent
The way you don't like it. Like, what are the terms, the definitions? Where are they for spherical geometry? Since we're dealing with the law of identity, where are the terms for spherical geometry as you're talking about? Where does it say about the definition of a straight line?
Yeah, so most introductory texts into spherical geometry will have. I don't know that there's a formal definition, that those axioms that Casey.
See, he just said at the beginning of this, he doesn't like the terms within spherical geometry. He doesn't even know what they are. That's a sophist. For him to say that.
Why is he even invoking the use of the word spherical geometry then if he doesn't even know anything about it?
He's a sophist. He's a practicing sophist. These are the people you have to deal with, and you have been dealing with for 6-7 years, however long you've been around.
Oh man, it's almost 8 now. Crazy.
Mm-hmm.
Yeah, I'm crazy. I know.
But you've listened to them say these words in conversations and had to let it bypass because you can't interrupt them to ask them what they mean. And they wouldn't be able to give a definition of them anyway. It's sophistry, and it needs calling out. Modern day.
Yes. And when he says that he doesn't like it, this is meaningless, because logic is not about liking things, but providing proofs, axioms, definitions. This is logic, and not liking.
Had a kind of not a formal definition. They're just the same deal. It's a convenience thing to help people.
Please, Darren. We are going over a serious logic course here, the law of identity.
Yeah.
You haven't got any definitions, have you? Because the law of identity of a straight line is that everybody knows it's a straight line. Everybody knows what a straight line is, and it doesn't change.
Yes, it's a series of points in space where the rate of change of slope is zero, right? There's no change in the slope, and that's one way to define a straight line. But but it's words, right? So like a lot of this situation, you've got to be careful that the English language, we overload our words, we overload our terms.
Is everybody aware of what's going on here? He's mentioning the English language. there is going to be a sophisticated way that these people will start bringing in the English language within definitions and meanings of words, and whether they meant the etymology of the word. Very wordy way round for definitions. You watch it, it's coming. I wouldn't change what a straight line is, please, Darren.
Text into spherical geometry will say that the great circle arcs we call them straight lines. Sorry, I'm cutting somebody off. I didn't mean to.
No, for Flat Rocky, are you talking or is
No,
this just hot
I'm
mic?
just going to ask you about a straight line, and it's very simple. Now, no contradiction. A straight line is a straight line. If you're telling me now that your straight line has a bend, that's a contradiction because it's not anymore a straight line. Now, I'll ask you this question. In Kingston, Canada, we had the Rideau Canal between two locks at 88.65 meters above sea level. The water between the two locks of 9.8 miles has a curvature. I can disprove it.
See, Flat Rocky, you did say it has a curvature.
Where?
No, but he said that he can disprove it.
Yeah.
That.
Proving that he was saying in his world.
No, you didn't say that.
No, but that's what I meant. Maybe I didn't choose my word right or the execution. But what I meant to say basically in his world, his line, I can disprove it.
You can't.
But I think that after that,
not in his mind, because that's where the concept of straight is. That's what we're talking about, the identity of straight.
But every curve, when you have a curve on a globe, it's defined by the size of the globe.
How do you define the curve then?
Well, according to what they're telling me of their so-called straight line that splits the globe in the center and defines us the distance between the North Pole and the equator.
No,
I'm playing his
how do you
game.
define it?
The distance?
You're talking about curvature. How do you define it?
Well, for him, in his view, he needs to show me water.
No. How do you define it?
Define it.
Mm-hmm.
Yes, make definition.
Oh, okay. Well, so
you're asking him, right, to give you something. Now, how do you define that thing that you're asking him to give you? How do you define it?
Then he needs to show me actual.
No, you
curvature.
can't define it with that he needs to show you. You can't.
Well, well, basically water bends, in my view.
That's not a definition, is it?
No, but not a definition. But if you tell me how to define, are you talking like to show it or?
I'm asking you, how do you define curvature? The very curvature that you're asking him. You just said it happens. It's there. How do you define it?
No. I said in his world. Well, that's what I meant. In his world, because everybody who thinks it's a sphere, let's say somebody imagines he's living on a globe, and he does. His globe is defined by a size. And what I meant, I should have been, again, I was in my hot tub soaking and I just accidentally had put my phone off mute and I was cursing in a hot tub. And basically what I'm trying to define is that what I'm measuring has no curve, contrary to what I was taught in school.
What are you measuring then? How do you measure no curve? What's that about?
In his view, a line between A and B where I can verify that the water is 88.6 feet, 88.6 meters above sea level. Between those two distances of 9.8 miles, it is level, horizontal. It does not have a so-called curvature.
How do you define the curvature? You said it again.
But in his world,
you said there is none of it. So how do you define the thing that there is none of? Please define.
If he was to show me curvature between
You've
the
said
two
it
locks.
again. You've said it again. That
Okay,
curvature, please define it.
Oh, mile square times 8 inch.
Mathematical, a
Mathematic.
series of numbers.
That's
Is
the only.
how
That's
you
the only
define it.
way. That would be the only way you could do it mathematically.
Do you know how a
but
definition's formed?
Pardon me?
Do you know how a definition is formed? We're doing logic and
Okay.
stuff, and we have done it.
Basically expressing the word, a curve is a bend in a straight line.
Within the formulation of a definition, you normally state what it is similar to, the same as, and then state a difference from the thing that you have stated. It's a relationship of something to something else to say that it's different. So you know that's how you define something.
Okay, so the best way to define his curvature.
No, just define the curvature that you're talking
define
about, not his.
So to define, if he was telling me that a curve, his curve, and I have to define it, I would say it is a straight line that is not straight.
So that would be contradiction.
And it is. That's what I kept saying. And that's how I addressed it. I said he had a contradiction because the water between two locks lays level and horizontal.
You're asking him to give you a contradiction.
Oh, for
surely.
him, exactly. He would have to show me.
Well, that's ridiculous,
Well,
right?
I can't find it. This is the thing. I can't find it. It's like a mystery. And in their imagination, they play with a mystery.
I think this is a developed argument that people have quite cleverly placed within this arena. Like, there is no such thing as curvature. There's no definition of curvature. You cannot measure curvature. Fundamentally, mathematically, it can't be done. So there's no definition of curvature.
So basically, defining curvature would be the opposite of straight. Of the opposite of a straight line.
That's not a definition, though, is it?
No. But that's what I would be asking him. And for him, I think he'd be trying to indicate where a straight line starts bending.
I think that's why the problem is with the curvature statement, because you're asking somebody for something that you don't even know what it is you're asking him for. So how would you know if they were to give it you? Because you've never come to terms with anybody about actually what this curvature is.
Well, his curvature is a fallacy. It's something he's telling me that exists. It's like saying that at the end of one lock to another, in his mathematical sphere,
you're gonna have to stop.
The water would
you're gonna have to start focusing it on him, right? Because this is you
but for me,
asking.
But if you're going to define me, what is curvature on the Earth? I says you can probably demonstrate curvature on a basketball, but you cannot demonstrate it in nature unless you have a tree that has a curve in it. That's not a straight tree. That's a tree that's bent and has a curvature. I can demonstrate curvature in that knowledge. But when we come to the sphere, I know I've tried my best, and I don't see any so-called curvature.
What sphere?
So to me, it's crystal clear beyond a reasonable doubt that what he's looking for is something he cannot find, and he's putting the pressure on people.
What's he looking for?
Oh yes, but on the same way, I explained to him, I'm showing you a straight line. What's a straight line? There is my view of a straight line.
But
Now, if you want to
the whole point of this is that his view of a straight line might not be the same straight line that you're thinking about. So you can talk about curvature as much as you want. He's talking about straight, the same as you're talking about straight. That's the whole point of this. We're dealing with straight.
So my line between two locks, which I found, and I've actually measured and see that the water is level and horizontal. If he sat there, in his view, he would acknowledge that the water is bending. They might use the word gravity, and I'll basically pull
He might
the same
use the
analogy.
word straight. He might use the word level.
Yes, he will. Because
then
level,
if he does, then no, but if he does mention that the water is level, then it contradicts his model.
No, no, it doesn't. The problem is that it doesn't, because he has different definition of straight line. So for him, bendy level is straight. This is his straight line. Here is the problem.
So his line has a bend in it.
Yes, he has bendy straight line. So
Okay,
if you are talking about the distance between
only
locks,
a mentally conceptual bend, though, right? The straight line stays straight. In reality, the straight line is straight.
Yes.
Okay. So if the conceptual straight line, right, that you imagine is straight.
Yes.
What if he imagines that differently?
Because he's going under the understanding that what he was taught in school, like most of us were, that we live on a planet.
He's just going off
that
straight.
Well, that's what he's talking about. The way he was talking that there's no straight line, and it was up to us to
he was talking about
rechange our idea of what a straight line was.
Yeah, that.
Because he's trying to persuade me to say that my straight line is a straight line that bends. If I was to give him from point A to point B, and he agrees I have a straight line, but he says my line has to bend, then, like I said, it's like a light switch. Your light switch is on or off. It cannot be on and off at the same time. So that's a contradiction.
Mm-hmm.
So when we're talking about where we live, if you're telling me your line curves or bends, your straight line bends, and my straight line is a straight line, then what I'm showing you is my example, but what you're trying to show is a contradiction because it is not a straight line.
Yeah,
in
you're
your
going to
view,
get
you might
frustrated, dude.
I'm not frustrated. I'm frustrated in a way, but I understand maybe because it's the way I'm expressing it.
No. I'm not saying, like, you're definitely correct, right? You don't need to, let's say, preach to the choir here. We all understand what's going on.
Oh, yes.
I'm saying you will get very frustrated with other people within this arena because they won't be able to hear what you're saying and they will stop you from saying it.
Usually people who don't want to listen are usually people who already have their mind preset on their idea.
Absolutely.
And in their view, they will approach me if I explain to Rita, which I do all the time, and they will say, well, it bends. And then I actually show them one of your pieces where you have horizontal water and water that flows to the right downwards. And none will say it's the one that flows down. But they will all say, hey, it's level on top, but it bends underneath. I'm like, no, it doesn't. I can show you the depth. I can show you. And they're trying to...
This is the straight line thing, isn't it?
Yeah, it is for them until they realize. And I even say to some of them, go take an afternoon, pack a picnic, go to the two locks, sit down, look at a map, and when you can come back and show me where the curvature is, I'll be more than happy to go check it myself.
Yeah,
but
see,
I know from
we're gonna have to take it out of the idea of you giving
take it out.
maps and
That's
stuff.
fine.
This is conceptual at the very heart of the first understandings of the law of identity.
But the conceptual, what I do, and if I show you two locks side by side, not side by side, but one lock entering into another lock, and if I can show you on a map, and I can actually go out and measure the water, knowing that water lays.
How do you
flat.
measure the water?
Here's the fun part about this: at each gate, at each locks, there is an indicator which is done by the federal government. Because like anything else, the management of the water, they have to know how the water is managed. So they're always, every day, they measure the locks to know how much water. So if there's one lock higher because they had rain off in that area and the runoff is going into the lock system, they need to be aware. It's water management of the locks. Especially when it rains, you can tell when it rains. Automatically here in Kingston, towards the emptying and the Great Lakes, anything that accumulates in the water that goes above 88.65 falls in an overflow, and it goes right into the interior lake.
Okay, so you get on the vertical datum, yeah?
Yes.
So that's where you've measured it, on the vertical datum.
On the vertical datum that they utilize, and they're basically measuring.
So that's like the vertical straight line.
Yes, a vertical straight line. Okay. And actually, on a small video I said, you see the plastic indicators that are at each of the beginning of the locks. And the locksmith just has to go out, check, and go, yep, that's the water. Because I've talked to the locksmith, and they've all had to, every day, they must write in the water level of their locks. It's documented, they know. Even some locks have special instrument to measure, to verify the water, the indicator.
Okay, yeah, we get that. Sorry. We do understand that. We've been to Bedford. We've talked to the guy. We do understand because there's a river on the other side. So it's just a vertical. What we're trying to get here is this is the mathematical concept of straight, the law of identity, not how you've measured something. The very concept of straight.
Straight to me would be the shortest distance between, let's say, A and B, and it's straight like a ruler. Like if I use a yardstick, that is straight and then measurable. So if you take your ruler and you try bending it, you're bending a ruler. Are you bending the line? Yeah, you could say you're bending the line, but it's not a ruler anymore because a ruler is meant to be straight. Now, a measuring tape, that bends.
But the law of identity of the ruler stays the same. It's still a ruler.
Exactly, because that is a straight line.
No.
The ruler's measured.
No, if you bend it's still a ruler. The law of identity of the ruler still stands. We're talking about straight, a concept, mental, existing in the mathematical realm.
How would I know a straight line in my house, the foundation pour? If my foundation is not, or my roof, like I built a garage, and I know that if it's not level, which level to me from point A to point B, that is
we're talking about straight.
I understand,
please.
Yeah, straight. No, but I keep staying with that. The straight. So once I've put my 2x4 against the wall and I nail it in, the right end and the left end are at the same elevation of the floor. And if I put a level on it, I'm seeing that my 2x4 rests level and horizontal. To me, on that end of the 2x4 to the other end of the 2x4, that is a level 2x4. And you can express it as it is a straight line between the 2 points on the 2x4. That's how I would do it if I was to try to explain to a carpenter.
We're dealing with the philosophy of straight. Let me carry on with this, please.
Okay. At 88.65 meters above sea level, the water between the two lots of 9.8 miles has a curvature. I can disprove it because both ends are at the same level.
It has
So
a
that is
curvature, did you
level.
say?
No, it doesn't have a curvature. In a sphere, it has a curvature. By me proving that water lays level, horizontal.
We're talking about the identity of straight. Yeah.
Yes. So
No,
I can show that a straight line is a straight line. Now, if you're going to show me or explain to me a sphere line, show me an example.
So,
in reality, in nature,
okay.
in nature's law.
Sorry,
nature's law.
Flatlockie, what we're dealing with here is just the identity of straight.
Yeah, and
Straight is straight. There's no other way. If you don't have a straight line, it's bent. It's a contradiction. It is not a straight line. This is what we're studying.
I know
What
we've
is a
already dealt with it. It's a circle, right? You can't have a circle without a straight line being straight.
And
because everybody knows it's a fundamental, right?
That we're dealing with great circle arcs, and they are conceptually.
What about vertical then? How about that? Is vertical a straight line?
Vertical is a straight line, yes.
Okay, so that's the straight line that we're talking about, right? You can't contradict that straight line that is vertical. Everybody knows what a vertical exists, and that's the identity of straight then, right?
Every common understood sense, yeah.
Okay. So there we go. That's how easy it is for us to agree on the law of identity for straight.
Yes, yeah.
Okay.
And we just need to remember that in spherical geometry, they use the term straight as a convenience term. It is not contradictory. It's just a word, right? We use words all the time to overload.
So how would you deal with perpendicular then? What would you think of that?
Yeah. So a perpendicular line is right angles to another straight line, right?
Brilliant. So they have to be straight, right? Our understanding of straight within the vertical straight deals with perpendicular, and perpendicular to vertical would be horizontal, right? That's the understanding of when we say perpendicular, right? There can be no misunderstanding with our understanding of straight and the identity of straight through the geometric terms of perpendicular, right?
Yeah, so if you're talking about straight lines and perpendicularity, it's clear, right? Yeah.
It's dead clear because two straight lines that intersect each other perpendicularly will form 4 right angles, and all 4 of those right angles will be equal. So if you curve either one of those lines, you would not end up with all 4 right angles being equal. So the absurdity of removing one of the straight lines is that you would fundamentally break one of the axioms of mathematics. And you can't violate the axioms of mathematics, because the axioms are there for a reason. Obviously, because straight is straight. There's no other way for this to occur with 2 straight lines intersecting each other at right angles. Very understanding of straight. Thinking of it differently somehow.
For me, it is not clear because in spherical geometry, let's say, we have this horizontal. That would be really.
No, we don't have a horizontal in spherical geometry. No.
Whatever.
Listen to him. They don't have a horizontal in spherical geometry. He said that out quite confidently. It's one of the things he knows. Whereas everybody knows that in reality there is a horizontal. So what does that tell you about spherical geometry with its relationship to reality?
That's why I had to rephrase it into level because I needed a line, this perpendicular line. So that was my purpose.
He has just given up his own model of relating to reality there by saying spherical geometry. Unless he thinks there is no horizontal in reality, like blue marble science. When in fact horizontal is anything that is parallel to the plane of the horizon. Weird in reality.
Level. What would you call this?
No. Spherical geometry doesn't come into reality. It's just spherical geometry.
So this line drawn, Darren, this line drawn on the surface of the sphere.
Yep.
How would you call it? Besides that, this is for you straight line, but what?
No. It's a great circle line, right? I know it's a great
okay. Great circle line. It is straight. So and this
straight in one dimension.
Great circle is perpendicular to vertical, and
straight. Have you heard that as well? Straight in one dimension. Like I'm not too sure whether he understands what he means.
I think not, because dimension is straight line.
Yeah, one dimension is the straight line, the actual straight line that he's talking about. So how can he have his great circle being straight in one dimension?
It cannot be.
I think what he thinks is somehow, right? Take this on as a concept. The great circle being a circle is within a two-dimensional plane. Right now, the other dimension of those two-dimensional plane is the one dimension that he thinks it is actually straight in.
Yes, it makes plane one-dimensional plane.
It makes the edge of the plane the dimension that isn't involved within the two-dimensional circle, right? The shape, the circle, obviously can't be straight, but the dimension that isn't within the two-dimensional circle that obviously isn't straight must be the one dimension that it is straight in, because it can't be straight within the two dimensions of the circle.
Can we not forget this is the same guy that wants to use terms colloquially? Like that, like in a normal conversation with a normal person, and you're just shooting the shit, whatever. Yeah, colloquial terms, whatever. But when you're having a discussion with somebody and you're trying to be poignant, you're trying to be precise, like that's when semantics matter. And you have to agree on terms, but this guy wants to have this and that at the same time. He wants to have...
Especially if you're trying to prove somebody wrong, right?
Yeah, I mean, that's the thing. Like, if it's like frantic bunny ears debate, or, an argument, whatever, you want your terms to be precise. You don't want to use a colloquial term. I mean, like, I almost butted in way like an hour or 2 hours ago when he was actually in, and you guys were talking about a plane, and I wanted to butt in and go, I mean, are you guys talking about a plane you fly in? I mean, because, like, you're okay with colloquial terms. I mean, I'm not sure what you guys are talking about. You know what I mean?
Yeah, I think that's a game that we don't play. Whereas they do.
Play it.
Yeah, they do, though. They need to. It's a sophist game, isn't it? And I prefer to come with straightforward arguments.
He gets like he got aggravated. I'm assuming it sounded like he got aggravated that because he said a couple times, this is, we're going around same thing. This is all about the terms, and you guys are hung up on words. And it's like, yeah, we're hung up on words because we need to know exactly what you're talking about, a definition of the word you're using, not a colloquial term.
Yeah, we were talking about the law of identity, right? Which is basically the actual term. You're dealing with the subject, which is what we've been going over, in the last 4 years or whatever, is trying to get to that subject. We've got ECV, we've got obfuscation, we've got definitional changes, but they do anything that they can do to stop and avoid addressing the actual topic, the issue, the identity of the whatever. In fact, they've made entire forms of logic so that they can allow themselves to do that. Way to ease their cog dis.
Yeah. I mean, you gotta justify. So it's like, I guess if your cog dis is what you like, the guy's here to justify his terms and whatever. It's like, but you can't flip flop back and forth between an exact definition or term of a word and using it colloquially.
Justify it to yourself. That's the only thing you've got to do. It's like a proof, isn't it?
Yeah.
Proofs can only be to yourself. So if you can justify anything to yourself, then I guess it's the sophist's way of finding the peace within proof. Or
And does he have a proof? I mean, have we even asked him?
No, but I think actually finding a proof for yourself gives you the idea, at least once you have the proof, then you can rely on epohe, right? I don't think epohe is a natural state to go to if you do not have a proof to start off with. If you never have a proof, I would imagine finding epohe really hard to do.
Well, you can't. I mean, you can't find epohe if you're in aporia.
Mm-hmm. Yeah. And if you end up in aporia because you know that one of the statements is that you can never have a proof, except for the ones that handed to you from a shadow giant with no reasoning behind it. Here's a proof.
Okay, I'm dropping to bed. Good night.
Okay. Night, Piper. Thanks. How much longer we've got of this? A few minutes at least. In one dimension, did you just say?
Yeah, it's on a plane, right? So if you look at it on the plane, the plane is straight.
Two-dimensional.
No. I'm saying that
He looks at it. He gets it on a plane, two-dimensional, and looks at it. That's where he gets straight from. The hula hoop type thing.
what you are using the straight in two different meanings in one instance, and this is
right,
not correct.
That we're mixing our terms and confusing things.
Yes.
But
Because
there is no
vertical.
confusion if you take the time.
Yes, it is because
you are creating confusion where there is none.
No.
You're creating confusion where there is none. Sophist. Terrible.
No. Wait a second.
We're talking about the identity, Darren.
We are talking about. We are
You're
talking
creating an identity where there is none.
We are talking about perpendicularity between great circle and vertical.
Yeah.
Yeah. So vertical is straight line, right?
Perpendicularity between great circle and a radius line. Can we use that?
And vertical. It is in your spherical
on Earth. Right?
I'm saying that vertical is straight line and great circle is straight line. In your
he doesn't want you to put the two together because they're obviously not. Right? It's a great circle is just a geometric thing. You've got to have that in the mathematical object realm, right? And a vertical obviously exists in reality.
So vertical does not
Yeah, I see
exist
what
in
you're
spherical
trying to say.
geometry.
We're mixing
No,
in,
no.
in the case. So we're moving away from the 2D surface into a 3D space again, right?
Yeah, there is no.
And-
Get you to say that, Darren. Remember, in spherical geometry, there is no vertical, is there?
Well, no, you guys were telling me it's a 2D space.
See, he says you guys are telling me. He's unsure what's going on with spherical geometry. He doesn't know. No, I'm asking you. Are you going to put a vertical within spherical geometry?
You can apply the two together, right? And that's what we do in celestial navigation. That we use the conveniences.
So you can have the vertical that is a straight line. You can have the vertical that is a straight line, and the other one that is also considered a straight line. You have the contradiction there.
Yeah.
Together.
So we talk about the straight line on the surface, and
Yes, because you are using them both in the same at the same time.
Yeah. And you have to be careful.
Yeah. He admits it. He's now using the two different forms of straight together at the same time. That's the contradiction. He's imagined another straight for whatever reason. No sufficient cause or reason for him to do that. Now he's got a problem.
Right, because you
can't
have to
do that though. That's the violating the law of identity of straight. Can you not see that?
No, I can't, because I know that they're not the same thing.
He knows that they're not the same thing.
Well, he admits he can't see it.
Yeah. I think there's a bit in here coming up now, which I particularly wanted to get in here, because he opens his mind up. He lets you see it, but you have to listen to it a few times.
And not the identity is not there.
So why are you naming them as the same?
I didn't name them.
We can call it arc because it is
call it an arc,
already
yes.
known as arc. What you are saying that this great circle is just circle. Yes, great or small or whatever. But you have another problem with great circle, because if a great circle is a straight line, so you can have different sizes of this sphere. It means that this great circle is curving at different rate if you are changing radius of the sphere. And you cannot say that this great circle, when it is greater than great circle, this is the same straight line.
No, that's it. It's like saying that if I have a straight line in Euclidean space and I change the slope of it, it's not the same straight line anymore, is it? That's what you're saying. That is actually an absurdity.
Yes, but we have in Euclidean, let's say, geometry and logic, we have only one kind of straight lines. So there is no different kinds of straight lines. But so
there is a logical saying, right? That the road down is the road up. Right.
So in Euclidean geometry,
it's the same straight line, yet it slopes in both directions, depending on where you are.
Use them. That's all. Anyway, we can continue on. We've distracted your conversation enough. I didn't intend to get into a fight over whether or not.
There's no fighting. We're talking about the law of identity, and it's obviously this is where it becomes shown that it's important that we understand exactly what the law of identity is and how that can be violated in every day with something as simple as the term straight, which there is technically no definition for, right? Because it is your first principle.
It was your first principle.
It is your first principle.
Euclid was on the earth, right? There are other tools available to us now to define straightness.
No, it's other tools available to us now to define straightness. So we have a straightness defining tool for defining straightness. It's amazing what technology can do for us, isn't it? So it's not something that needs a definition. It's a mental construct that you have to have for yourself.
Yeah,
A fundamental reasoning principle. First principle.
So when I work in spherical geometry, I have a mental construct. The mathematical definition and my mental construct are different things. So you have.
Do you hear that? Want to go back? Yourself.
Yeah,
a fundamental reasoning principle. First principle.
So when I work in spherical geometry, I have a mental construct. The mathematical definition and my mental construct are different things. So you
different things. The mathematical definition and his mental construct are different things. There you go. That's the unspoken truth within all of this. That's why you never get an answer. Why nobody can ever identify the thing. Because he can't define what he has in his mental construct of the thing. Because it's different than the mathematical definition.
The mathematical definition and my mental construct are different things. So you have your mental construct about a straight line with its corresponding mathematical definition. When we work in spherical geometry, we have a mathematical definition of this line that we call straight and a mental image of it as well. Those two mathematical definitions are different.
They're different. Mentally. They're different. Yeah, I know. I've been saying this for quite a while. We did make Imaginometry. I was wondering how to cut this up. Don't know whether I should be doing that just yet. But I think this is one of the things. I'm pretty sure that he's read Imaginometry because anything in reality can be imagined differently is one of the postulates, I think. And he's just basically said it out loud. I don't know whether I gave him that from Imaginometry or whether Imaginometry was the way it has to be, whether we predicted it. Thank you. Right. You just have to think of it differently. I think that was wrote in Imaginometry. It's one of the axioms, maybe even a postulate. Probably a postulate. Anything in reality can be thought of differently, perhaps something like that. Yeah. They're not that. Right, because you're taking straight, which is obviously that everybody has a first understanding of, and you're saying, well, that, but not that.
Yeah, but what about your law of identity that level and straight are the same thing?
Absolutely.
And what is that? Just an axiom that you've just made up?
No, I've proved it.
You keep saying you've proved it, Bev, but you've never actually shown me this proof. I'd like to see it one day. We won't do it today, but I'd like to see your proof.
A proof is something that you have to gain for yourself. Does anybody think that you could actually prove something to Darren? Do you think he would accept a proof? You know, within the understanding that it has to be taken on by the individual in order for them to gain the proof individually. I'm not too sure whether anyone could give that to Darren, because I don't know whether he could accept it. He thinks differently about a straight line. So how does that mathematical process work? How does the thought process, where the mathematical realm is, if he thinks differently about the mathematical idea? I don't know where he thinks mathematical, the mathematical part is. If the vision, I don't know, the imagination. And I'm not too sure where it all fits after going over the divided line. I can walk you through the mathematical principles of it. I can even show you the materials for you to get the apparatus and all of that sort of stuff, for you to be able to do a similar test.
Yeah, and I'd also, can you walk me through your test as well?
Yeah, that's the same thing. You can do it for yourself, yeah.
I don't necessarily have the equipment or the right space to do it myself, but I'd like to see your test, because that's the way my philosophy works, is that I can take something that somebody else has done, I can learn from it and
reproduce it,
analyze it for myself.
Yeah, that's why the whole point of walking you through it from first principles. But
yeah, so
starting off with straight is one of those things, right? I can run you through it, yes, definitely.
Yeah.
So we can understand from these first principles and the law of identity of all of these things. The main first principle is straight. Of any sort of, I'd say, deductive reasoning, you have to have an understanding for the law of identity of particularly straight, because then you can go into geometric reasoning, deductive reasoning.
Yeah. But you can't deduce from the statement that something is straight. You can't then go and deduce that it is straight, right? That is not deducing anything.
No, you can prove it straight once you start off with
through
the understanding
your
of what straight is.
Demonstrating that level was straight. I don't believe it's been in any of your YouTube videos. So
just because you haven't seen a YouTube video does not negate the fact of the geometric reasoning behind straight. That being the first principle.
I'm not disagreeing about the geometric reasoning of what straight is. I'm just disagreeing that it may or may not be level. But anyway, we'll leave it for that.
Okay.
For another time.
Jolly good. So yeah, we go through these terms. Law of identity, obviously. There's some people who might argue about the law of identity. And then the law of the excluded middle says each thing either exists or does not exist. Each proposition is either true or its negation is true. True or false. One or the other, on or off. Straight or curved. There is no middle ground in between. There's no a little bit straight before it gets into the curve. It's either straight or curved, on or off, true or false. There is no middle ground. And then the law of non-contradiction. A thing cannot exist and not exist at the same time and in the same relation. And then we did have the double negative as one of our things. I don't think we ever really had the sufficient reason. Has anybody else ever heard it other than paper? I mean, it makes sense. But what would be the sufficient reason for wanting to change straight? For wanting to say that not straight is straight? For you know, what would be the sufficient reason for having to do away with the law of non-contradiction and the law of identity? I don't know. I'm not too sure whether it excludes the law of the excluded middle. It doesn't violate that. Just changes the law of identity and non-contradiction. And obviously sufficient reason, because I don't think there could be a sufficient reason for anybody wanting to violate any of those. Not in my book, anyway. Makes sense. Probably something that I've not been relating to either. Sufficient reason. It does add it into it. What would be the reason? I think that's a bit obvious, isn't it? Same answer as always. Spherical geometry. Why what would be the reason for spherical geometry? For violating geometry, making a stolen concept. Okay. Back to what would be the reason for wanting to violate all of those laws? To make straight not straight. I think that's one of the things that we have to be watching out for. Why get dragged into an argument about why straight can't be straight? Oh, thanks for coming here, Blue. Nice again. Blue Marble Science. The old perpendicular 180 degrees. It's rather weird to put it all together, but I think it culminates in this particular thing, straight. People's concepts of what straight is. And I guess that's where we might end up being different. Because I know that Darren thinks that straight can be different. I just don't. I'm not willing to do that. Call me crazy. But straight is just straight. Doesn't change to something else. Because that leads to contradictions, and everybody knows that there is no contradictions in reality, so the real globe cannot have contradictions. Simple as that. I definitely live in the reality where there are no contradictions. In my world, there are no contradictions. And if I spot a contradiction, then it means they've got some sort of faulty reasoning. Needs fixing. Although Darren's, thank you for coming in, Darren, again, once again, explaining the differences between different people's understanding of straight. We're going to end up with one of the favourites. You have to listen to these lyrics in the songs, Buster. It's Free for All Friday tomorrow. I don't know what the conversation's going to be. We've seen some weird stuff in the Discord servers around here. I don't know what's going on. Power plays. Maybe we can talk about that. Maybe we can talk about the law of identity and some of the Aristotelian organon and the understanding of logic and all the philosophy course that we've been going over. Join us tomorrow. And yeah, once again, thank you very much, Darren, for coming in, helping us out with the how to violate the law of identity regarding straight. And still showing that there's still chance of discussion around some of the most basic first principle ideas. Join us tomorrow. See you then.
Balance and so much more. It's getting clearer all the time. All we see are all these dead straight lines. And show me what's in reality, and I won't compromise between the truth and lies. This is where I make my stand. Please don't take me to your la-la land. It's all about geometry. All we see is horizontally. Show me what's in reality, and I won't compromise between the truth and lies. Show me what's in reality, and I won't compromise between the truth and lies. Reality is all I see. I don't need your fantasy. I've had enough of sophistry. I'll find my own philosophy. Reality is all I see. I don't need your fantasy. I've had enough of sophistry. I'll find my own philosophy, and you can't bend reality into what you think your cog deceives. Something's happening to me. Don't remind me of how